PC-DMIS users in the group here. And when I first started, like in 1990, PC-DMIS was like this goofy little option on the side. You want to use CAD data with your CMM, and if you are, we've got this special program, and it's a bunch of money, and very few people bought it. 1990. You get up to 1997, and it's more and more popular, and it became the core product. And that was good times for us, because we'd go to customers and say, well, do you think CAD and CMM is important in your future? And they'd all raise their hands and say, absolutely, I've got to have CAD with my CMM. And we got all kinds of orders, because that was kind of the first software that did that. The only issue was that you'd work with these people, and 1 year, 2 years in, they're happy, they're using PC-DMIS to make all their programs. The one thing they're not using is CAD with PC-DMIS. And so they know the future is there, but they're not quite there yet. And now I just asked Brian McDonald, confirm what I think, our application guy. How many times when you talk to a PC-DMIS customer are they using CAD for programming? 90% plus. So from about 0 to 90, and it ramped up pretty quick. Within 4, 5, 6 years, the majority were using CAD data to write their programs. The model-based definition is kind of a similar sort of thing. Right now, when people are thinking about their software and what does the future look like, we talked about buzzwords, and the whole model-based definition is becoming more important. Yet I know in our lab, where we have about 1,000 new jobs come in every year, and probably the majority of the jobs have some kind of CAD data, and of that, maybe 5% at the most has model-based definition data. But we know it's all hanging out there, and we know that it's starting to come in. And we had a demo for a customer, and we said, hey, get us the CAD data, and they gave us a model-based definition file. We go, holy cow, look at that. And every so often on a contract inspection job, people will bring in a model-based definition job. So it's really a good thing, and that's what we're going to try to show you today. And the intent is to say, okay, there's lots of different ways to do this. Here's how we do it in our lab. When we see a model-based definition file, what do we do? And so this is kind of like your slideshow. The only issue is that this slide is really, really, really long. So we're going to kind of work our way through that. And so the meat of the thing is simply to say how we do it in our application here. And these are the guys who actually do it, so they're all going to get up and talk about their role and how they make it happen. But to begin with, we're going to start with kind of an overview of QIF. So I'll just do a few introductions. Greg Hetland. I think many of you know Greg from doing all our GD&T training. And when I look at Greg, I'm supposed to think that there's GD&T posters back there available if you'd like. Tom Groff is next up. He is the Vice President of Enterprise Solutions for OGP. And you know when he was an application engineer, which essentially at OGP, that means he's the guy that has to kind of direct the future of the software. What are they working on? What do they see next? What's the long-term future look like? So Tom is going to talk about the QIF standard model-based definition in terms of what OGP is doing and what they see coming up. So he'll be kind of the meat of the what this is. And as long as you got some people in the back, quickly introduce yourselves, and he can
take a while. We have a lot.
Yeah.
Matt Rindall, I'm president of Productivity Quality Inc. I do what he tells me.
Brent Bollinger, Capital Sales Central Area Productivity.
Andy Burchett, Calibration Account Manager for our calibration department.
Michael Yeager, Portable Sales for Hexagon.
David Balco, Stationary Sales for Hexagon.
Ryan McDonald, I'm application engineer for Hexagon Products.
George Hatcher, Productivity Quality. I do what Matt tells me.
Bill Schultz, Central Region Sales Engineer.
Chris Carlson, Sales Engineer, Capital Equipment East. Craig Van Was, not Capital, so Calibration and Gauge Sales for the East Region.
Peter Varanasi, Calibration Gauging Sales for the West.
Oh, we might as well do the four guys sitting down too.
Skylar is Palmer. I'm a sales engineer and I do contract sales for advanced inspection services.
Nick Scusa, AIS or GP app support. Rich Horsmo, AIS manager.
Chris Azra, project manager for AIS.
These guys will get their chances later when they have to come up and talk. And so again, what this long thing is how we think about it, how we think about model-based definition. And of course, there's another one that's all convoluted and goes around and around in circles that says, hey, here's the whole flow chart with every possible path. But this is kind of the simplified version of that. And in our presentation, we're going to talk about project managers, which is kind of what Chris, Skylar, and Jake do, where they would interface with a customer, and the customer would say, hey, here's what I need done. Here's my inspection requirements. Oh, it's CAD-based. What kind of CAD data am I going to get from you? And in most cases, it's going to be a nominal file, a step file. Occasionally, now we're starting to see some of the model-based definitions. In many cases, it's a QIF file. Lyle, Fisher, right there. And when we get a QIF file, so well, I design in SolidWorks, I design in Creo, I design in NX. And somehow we've got to get out of there into this generic format. And Lyle works for a company, Capvidia, that enables that. So in some cases, the CAD software may say, hey, I got a QIF out. But if they don't have a QIF out, then we would work with Capvidia, and that's what we did here. So we have SolidWorks in our design area. And so, gee, I've got a SolidWorks project. All the dimensioning is in there. And now I want to get to PC-DMIS. Capvidia enables me to get from there to there with kind of an add-in sort of thing that enables that. Did I say that okay?
Correct, yes.
We got it. Okay, so that's kind of our first step. But now, from there, okay, what are we going to do? And so this is kind of our flow going all the way through and different people doing things. The project manager, which will be Jake here, he starts it off. And then once Jake kind of gets things defined, he says, okay, we got to make a program. This is a vision program. This is a PC-DMIS program. This is a scanning or CT program. Goes to an application engineer. And so these guys are going to get up and say, okay, I get this. Here's what I do in PC-DMIS. Here's what I do in Zone 3. Here's what I do with CT or other scanning data. And then eventually what we've done and what's kind of made this less painful is that we've built some automation in. And so we have a number of customers who say, I want all of my data analyzed in SmartProfile. So we get points from a multi-sensor, from a CMM, from a scanning system. And so now I got the points, I got SmartProfile, I got to do all this importing. And a ways back, that was kind of a pain. That was all added time. Adam is our director of metrology, and he does a lot of our SmartProfile applications. And so we have like a point server. And so when we make this SmartProfile project, it just sits there and waits for the points. Ah, there's the points, it grabs them and executes it. So there's kind of an automation and auto process step in this. So these are the guys who are going to talk about how we do our stuff once Tom lays the foundation of what all this stuff is.
Is that Q?
That's the cue.
For me to come up? All right. Thanks, Keith. Hello, everybody. I'm Tom Groff. I've been around a while. Originally, as Keith said, I started as an application engineer about the same time Matt started as an application engineer, and we did a Europe trip together as application engineers back in the day. So a lot of history with PQI. Thanks for inviting me to the event. Thanks for coming to the event. My role now is really all about what this seminar is about. It's trying to figure out how to enable this digital enterprise for you guys, for customers, and trying to develop tools, both hardware and software tools, to make that transition easy, and so that our customers, you guys, are efficient and have the tool set, some people call it a technology stack, to enable you to you know, use some of these new ideas and whatnot. So bring up my presentation here. Yeah. So do we have a clicker? Is there a clicker? Is there a clicker? Okay. So there's a lot of buzzwords out there about, you know, model-based enterprise and Industry 4.0, the digital thread. If you guys have heard some of this stuff, that's probably why you're here today. You know, to get more education on that, understand it better, learn how you can use some of these things. So I was at IMTS at a seminar, and you know, we had some breakout sessions with some small groups, and it was interesting. I think it was the digital thread term came up, and you had like 8 people at the table, and we all went around and said, what is your definition of a digital thread? And vastly different answers came up, right? It's like, it depends on your discipline, what your role is, what your interest is, and how you interpret these certain buzzwords. So I'm gonna open it up. Anybody want to take a shot at defining, let's say, Industry 4.0, bottom right? What's Industry 4.0? This is
3, 2,
this is an
1.
engagement. Come on, somebody raise their hand. Yeah? Yeah? Digital thread, anybody? Anyone know? This is great. Wow, I can just flood you with information then. So, no. I wanted to get some input because I'm interested to understand what you know, people think these terms are, and it's understandable that you don't have answers because that's why you're here. What I'm trying to do here, I'm going to go through each of these things and give you my interpretation of what they are and how they can help you. Okay? In simple terms, I'm going to talk about the digital thread. If you do an analogy to Google today, when you do Google Maps on your phone and you say, I want to go to this location, right? You know, it might come up and say, okay, yeah, it's going to take you this long. You know, it's going to take you 10 minutes longer than it took you yesterday because there's traffic here. How does it know that there's traffic there? There's digital information on the internet somewhere in you know, some magical space that says there's a delay. Or you might say, I want to order some pizza, and it might come up and give you your, you know, your recommendation because you've ordered at this pizza place before, and you like pepperoni and sausage. You know, that's digital information on the digital thread. It's a database of information that Google stores about you, unfortunately or not, depending on your perspective on this whole thing. Some people love that that information about them is there because it helps them day to day. Some people hate that that information is about them because it's intrusive, right? So when you think about that analogy and bring that into the manufacturing environment, the digital thread is a database of information, but not on me as a person, it's on a part. Okay, a manufactured part should have as much information about it as it can in a digital world so that it can be communicated from this software to this software, this machine to this machine, and not have as many manual, personal, people interactions, because that's where we screw up. That's where quality errors come in, that's where misinterpretation comes in, and all that stuff, and where inefficiencies come in. So when we enable this digital thread, this database of information on a part that says, this is how you manufacture the part, this is how you inspect the part, this is how you package the part, this is the data of all of the quality information, all of the historical reports on that particular part that is made over the last 10 years, that's the digital thread. Everything about that part exists and is accessible to software that you might want to analyze it. So whether you're a VP of a company, or whether you're a quality engineer or a designer, you have access to that digital information for whatever purpose you want to use it for. Maybe it's to make strategic decisions for your company. Maybe it's so that you understand how to design a part better. Maybe it's so that you don't have to program a CMM. you'll learn that, you'll see that happen later today. Okay? So that's the digital thread. Oh, cool. So we're also, I'm going to go through each one of those terms and just give you a little understanding what that is. So Industry 4.0, again, a buzzword. A lot of people don't really know why it's called Industry 4.0, what that means. But basically, it's the next phase in how we do manufacturing and how we automate things. So you look at Industry 1, Industry 2, and Industry 3. Those were real things as well. The most recent one was automation. What's an example of automation? What's that?
Cars.
Cars, yep. Cars was automation. Something you guys probably interact with every day, a CMM or a smart scope. That's an automated tool. So that's really Industry 3.0, okay? Industry 2.0, you think about the most well-known is the Ford production line, right? Mass production, assembly line kind of stuff. You know, and so each phase as we go through eras, really, you're making our lives as humans more efficient. So Industry 4.0 is taking Industry 3.0 and connecting the dots. So I have this automation thing and I have this automation thing, and they should probably be able to communicate to each other so that that information can flow from, you know, a CAD system, which we're going to talk about today, to a metrology system, to a data analysis system, and all that information is connected to each other, and you gain efficiencies. So that's really what Industry 4.0 is about. And there's actually Industry 5.0. Anybody have an idea what that might be? Who's that?
Autonomous.
Autonomous, yep.
AI.
AI, yep. Intelligence. It's the scary part. Making all these machines smart as we are, smarter than we are, potentially, and being able to make intelligent decisions is really Industry 4.0. I mean 5.0, which is not on the chart. Interesting nonetheless, yes?
I worked for a company called Lowell, Incorporated over in Brooklyn Park. And they had something I had never seen before, and I just wondering if it's Industry 4.0, where they had an actual robotic arm that would actually talk to the CMMs. So what it would do is it would register a pallet that had parts on it.
Yep.
It had a diameter on the corner of the pallet, and so the robotic arm would pick up the pallet, put it on the CMM. The CMM would go and take the diameter and be able to register. But they would talk to each other to see if the CMM was available. Is that considered 4.0 or 5.0?
That's really 4.0 because they're talking to each other. If you think about a robot by itself or the CMM by itself, that's 3.0. It's a great example though.
There's a picture of it in our conference room.
Yeah.
That we worked with it. Jim Sturts was the guy who put that all together.
Yeah, he's my college professor.
Oh, okay. So you got a picture of Jim with his arms folded, standing in front of the machine.
Yeah. So Matt took me, after we were done yesterday, he took me on a walk next door, just right across the hall here, into their automation area, right, where they do all of that automation. So really cool. They've got tons of robots back there. But when those robots are communicating, you know, to the manufacturing system that's supplying parts, grabbing the parts, putting it onto a smart scope or a CMM, and it's telling the smart scope that it's ready to go, that's Industry 4.0. That's machines talking to each other. It's software talking to each other. There's no people involved in that whole thing. That's what really great example. Thank you. So let's move on to another one of those buzzwords, model-based enterprise. Who's heard of model-based enterprise? Okay, so that means what Keith said, taking a CAD model. So I'm gonna expand upon what Keith said about the using a CAD model for CMM software. Okay, the president of my company, Terry Polidor, really old fart, right? He's old school, but he looks at this stuff and he goes back a step further. He's like, I remember when everything was designed on paper. He was an engineer by trade. He drew things to say how a part needs to be manufactured. And he talks about the transition from a paper-based design world to a CAD-based design world where the CAD system was not even a model at that time. It was just creating 2D prints, and then the transition of that into a 3D model in the CAD system. And now you're using the CAD model in a software, and the next step is embedding that model with a bunch of digital thread information so that that model can contain information to do things more automatically downstream. So basically what it is a CAD model that has a lot of stuff connected to it. Okay? It can trigger how to do an inspection. It has all of the GD&T information embedded in the model so that that's known for downstream processes. You can feed back information back into the model once you know that problems might be happening and fixes will be needed in the design. You can have that closed loop system. So PMI stands for production machining information, I think, manufacturing information, something like that. But it's basically the tolerant. It can contain. That's the information attached to the model. That's the term for PMI. Tolerances, inspection methods, what tools, what resources you have, what machines are used, what sensors are used, all of that stuff, how you measure parts, how many points on a particular feature, all that stuff can be in PMI information and attached to the model. And why would you want to do that? Well, one example is that your automated measurement machine can consume it and create an automatic program from it, and and do it without any manual interaction. So that's model-based enterprise. It's all about CAD model information embedded into it. One more buzzword. Sorry, I keep doing buzzwords. QIF. That's the name of the seminar. Is how to use QIF. And I kind of object to naming the seminar that because QIF is it stands for Quality Information Framework. It's basically a XML file that has all of this information in it, this digital thread information. Okay, and the reason QIF is cool for all of us that are quality oriented is because it was designed for quality. Okay, it has quality information in it. That's the name. Okay, so it's characteristic based. A characteristic in terms of QIF is a GD&T callout. A feature is a geometry. So a characteristic might be a profile tolerance, and a feature is a cylinder. Okay, that's the difference. And so they have these what they call elements that have that information within them, and they're all connected to the features in the model. And so I was going to try to explain all of the details about QIF, and you guys don't give a crap about that. You really want to know how it's used. So I recognize myself that QIF is really what I deal with on a day-to-day basis. I make software to be able to use this information so that it's easy for customers. You guys will deal with model-based enterprise. So you have a model and it has QIF information available in it, and this should be transparent to you. But you know that all that information exists in the model. So that's really what it's about. This third section here, information semantically linked to the model. Okay, you see there's a little cupid down there. Okay, each feature, each characteristic, each model, everything in a QIF file has a cupid associated to it. Not the cupid that shoots an arrow, but it's a unique identifier number. Has lots of numbers on it, so every number is different, and it allows traceability from a report that might be on this certain characteristics on a part that I have, all the way back to the model. So the feature, the report on the cylinder that I have as a tolerance, and it's in or out of tolerance in my report, that can feed back to the model, and it can say, okay, well, I know that that's directly linked to this model that was designed for this purpose, for design intent. So more on that later, but that's the really cool thing about QIF is that you have that traceability and that connects everything together on that digital thread. And another nice thing about it is it's a standard. So, you know, it is intended to be a standard so that everybody can use it. All of the vendors like me and Hexagon and you know, all of the companies that make software and hardware. But it's also, you know, you can be comfortable that it's transferable and that you're not getting stuck by one OEM's function and not being able to use it across machines.
I have a question.
Yeah.
Is this going to be something that is like HD DVD versus Blu-ray, where different people, some new standard might come out that certain manufacturers choose over another? What's your prediction?
Really good question, because you think about the predecessor to this was DMIS, another standard, right? That was intended for quality to be, and this is really the new version of DMIS.
Okay.
So I suspect that it's not going to be the end of the world. I mean, or that this isn't going to be the end all. It always evolves as we need more information and stuff. So I think that this is a really good. It's very modern. So it's based on the same kind of technology that Google uses to track information and to link information. So I think that will make it long lasting.
Okay.
But inevitably it'll change and evolve over time.
And it's kind of an additive thing where
yeah.
you can have QIF, I'm going to have the next thing and the next thing and the next thing,
Yeah.
but QIF will probably still be there because
Yeah.
once it's available and implemented, there's no reason to take it away.
Yeah.
As
And-
opposed to my data player at home. Which
Yeah, exactly. And it's architected in a way where if there is another standard that's for another purpose, they'll be able to communicate to it.
Okay.
So,
Great.
yeah. At least that's the theory. Who knows? That's the problem with standards, so I totally agree. You know, it's hard to make a standard that everybody can use. Me being a vendor that worked for OGP, so I design software and hardware, and I have competitors, you know, that I want to be better than them, and so I do things differently, and I want to make it exclusive to us. So it's, you know, you have these vendors that are always trying to not have standards so that they can distinguish themselves. So there's always that battle, but I think we recognize that, you know, having a standard allows for our machines and software to communicate to other devices. It just makes it more marketable and a better product. So most companies are starting to realize that's true. So good. I paid him to say that. It was a good segue into my next slide, right? So look at the history of QIF. It started out DMIS 1.0. I was on a DMIS committee back in the 95 era when they were thinking about integrating video measurement stuff into DMIS. And it was kind of a nightmare, to be honest with you, but it is used, you know, and DMIS was the standard for being able to bring a common formatted file onto metrology systems so that they can be programmed in a similar way without having any restrictions on who the supplier was. But anyway, this is a timeline. So you can see in 2013, QIF was developed as an ANSI standard, and it was really a branch off of DMIS, and it's modernized and continues to develop and add features and characteristics to it. And just in 2019, it was accepted as an ISO standard, which kind of escalates a little more globally. So, since this seminar is labeled QIF, I felt obligated to kind of explain what is in a QIF, or what could potentially be in a QIF file. And let me say this before. QIF is not a single file, it's a network of files, potentially. So you can have a QIF file that is a report that has the inspection data in it, the real answers. You can have a QIF file that is a model. You can have a QIF file that has GD&T information in it. They can all be separate, but they talk to each other. They can all be one also. You can have all that embedded in one QIF file if you want. And not to get too in the weeds here, but that's the idea. This QIF file that lives over in China and a supplier, and this QIF file that lives in California who designed it over there, and somebody here in Minnesota has a QIF document that has the GD&T information so that they can create and inspect parts. They can all be communicating to each other potentially. and that's the modernization of it, is, you know, it's more of a global connection than just a local connection. But let's go over what's inside of here. Is this a pointer? No. Oh. So if we start up in the upper right, that is the CAD. The geometries, the features, the cylinders, the planes, the surfaces, that's CAD. Also, this, you know, that's really the definition. So the PMI, the GD&T, the characteristics, that's all in the MBD, model-based definition. Definition of a part. How it's defined. What defines that part? You go down to the right into plans. So the bill of characteristics is characteristics or tolerances, okay? So the list of the critical features that you want to measure is called the bill of characteristics. And that is the what. What do I want to inspect? Okay, that's also in the QIF file. The inspection plan is how do I inspect it? What machine do I use? What probe do I use? How many points do I measure on a feature? What uncertainty is in it? You know, all of these things can be embedded into the QIF file. That's the how. Also, resources is in QIF file. That's what do I have available to me to use. So, you know, you at a company, you might have Brown & Sharp CMM, or you might have a Smart Scope, or you might have an ARM, or you might have a CT scanner. These are all resources available to you to be able to measure your parts. So ideally, you'd have a list of resources, and those resources are matched up to the bill of characteristics, and they say, well, because you have this tolerance, you need to measure it this way, because your other machines aren't able to measure it. It's not accurate enough, or it's inside of the part and not outside, those kinds of things. And then rules down here, another thing that can be embedded in a QIF file. Rules are things like, you know, you might say that if it has a tolerance that's this tight or more, you need to measure it on a CMM. Or you might say that, you know, if it's a part that's you know, bigger than this, you need to measure it with a portable arm scanner or a laser scanner or something like that. These are the rules that you can define, and what all this stuff allows you to do is kind of automate how you're going to inspect it, or at least tell a downstream operation what the intent is and how you should measure it. And the DMIS just allows the QIF to connect to machines that are measuring. QIF results is the complicated part, I think, in QIF. So the QIF results is, you think about an inspection report that has all of the bill of characteristics and the results, and whether it passed or failed. That's ultimately what we want when we inspect something, right? That's the results. So you'll learn in Keith's workflow that you can output in a lot of different ways from any of the machines that are in AIS or in your labs. You can output to a PDF, you can output to a text file, you can output to a stats output so that it's in a historical database. You can also output to QIF. QIF is kind of a more machine readable output. So it's not something that you know, the president of your company is going to look at and understand. That's a PDF report or a model-based report. But the QIF might be used for historical purposes. It might be used for downstream operations, and that's really why a QIF result exists, is so that you have this common connection, and machines can interpret the results and do other things with it. Okay. And then the purple one up there is taking those QIF results and putting them into a database, statistical database. You'll learn that the stats package that we make is QIF based, it's model based, so that when you drop stats, your data into our stats package, it's all back connected to this digital thread all the way back to the model. So that's the whole scheme.
All of which makes me go,
TMI?
the whole theme here, what we're doing today, is essentially one. And some things we really don't care about in our process flow. I think 6 results is something that we kind of see as maybe the next step in what we're doing. And then 7, I don't know, Greg, I can't think of anybody who does everything right now. It's a big deal. But if you want to, you could.
One of the bigger things with the group that's in the room is we measure things for 2 reasons. One is proof of compliance, the other is the process and design feedback. We know we do a terrible job talking to manufacturing because nobody trusts the answers anyway. But that goes for design as well. This data is intended to be flowing back up through design in a way that we can trust, which associates those uncertainties that Tom was referring to in a kind of map, right? Kind of inventory knowledge stack analysis, right? So without this data being traceable, tied in like Tom's talking about, we can't get there, right? It's a roadblock, right? So we need to go more. The other reason here, anybody ever used an IGES file versus a step file? Those have translation errors in there, right? QIF, no translations, right? You're not working with that. So there's other motivations behind some of these changes as well, right? And I still remember, Tom, that paper version that I used to graph on as well.
Mm-hmm.
For the old
Yeah.
days, it's sort of clear.
It's because you have gray hair.
I know.
I have gray hair too, but it's only not here. Thank you. So a good point though, nobody's doing all this. Don't be intimidated by all this. This is a pie in the sky ideal vision of how all of these things would interact and play together, and the kinds of information that you would need to make that happen. So that's what QIF was designed to do. Provide the information so that these things, so that we can enable those kinds of communications to happen. So I haven't seen a QIF file with all of this. In fact, maybe just very minimal part of this, mainly the GD&T information is where we're starting with all this. But you can see how expandable it is, right? So how does all that play into what you do on a daily basis? Okay. So when you think about how all of this gets applied, the first part of the workflow is you have an engineer designing a part in a CAD system. Okay. He's designing it with tolerances in mind, knowing the design intent of the part, how it needs to fit into other parts, or how it needs to perform, what the material needs to be like for stability. That's what engineers do on a daily basis. They design stuff. Okay. And the thought is that you can bring some of the requirements in downstream operations back into the design process so that they're also defining potentially how to measure it, what machine to measure it on, because they know the resources available. This is all information that's in the QIF. So out of the design process comes a QIF MBD, a model, that is a CAD model. Everybody knows what a CAD model is. This CAD model is richer now. It's got more information in it. And so that CAD model can be consumed and used for other things. So that's the output. So the blue things here is the part of the process. The yellow things are what's resulting out of it. So out of the design process, you get this rich model. Okay? The rich model is then moved into determining the measurement requirements. So now that I know, the designer put in GD&T information, now everybody knows downstream what needs to be measured to be able to say, yeah, that's a good or a bad part. Measurement requirements is defined at that point, okay? So what's the output of measurement requirements? What do I do? How will I inspect it? That's the yellow QIF plans, okay? The what's. So that's what comes out of the measurement requirements. So once you determine the what's, go into defining the measurement process. So I've defined what I need to measure. Now how do I measure it? That's the how. And what? What do I use and how do I do it? That's the measurement, the definition of the measurement process. Again, all this stuff is in the QIF file potentially, okay? And so if somebody in that realm, this is usually all of us, defining the measurement process, you know, now that you've done that and embedded that into the model, now it can be used downstream, and then the execution of the measurement process. So now I take this QIF file that the designer made, and somebody smart defined the measurement requirements, and somebody smart also defined how they were going to measure it. Now I just open it in Zone 3 or PC-DMIS, and I have a measurement routine. Oh. Somebody hit the easy button. Boom. You don't have to write a measurement routine. You have the information in there. There's no potential for somebody entering a tolerance in wrong or typing it in wrong, or there's no misinterpretation of the GD&T standard, which is, you have to have a deep knowledge of GD&T to program a CMM. Don't need that. Okay, so that's the execution. So now you run the part. You got the program, hit run, measures part, I get results out, boom. That's the data output. So the QIF result goes out. Now anything can analyze that individual report, or many reports of that same part, or many reports from multiple factories, or many reports from different machines that made the part, many reports from different machines that might have inspected it. You can dive down into that information and understand problems or strategies, business objectives, all that kind of stuff. So that's the analyze part of it. You guys following me so far? Okay. So you'll see this workflow in different formats throughout the day today. This is the QIF concept of the workflow and how the QIF file is used to enable this workflow. So when you walk out of here today and you say, okay, so how am I going to use this in my plant? Think about this workflow. You'll see a version of this workflow that's product-based. Of course, I'm here because I work for a company that sells products, and I'm trying to promote our products. We have products at each part of these stages that enable you to get through this process, okay? So you'll see this workflow in product. You'll see this workflow in services. These guys up here, they do contract inspection, and if you give them a part and say, I need results out, they're going to go through this process that Keith has defined with that big long presentation. That's a workflow, but that's a services and process workflow. So what do you do in the process, and how do you enable this, either as an inspection service company or as a company that you are doing yourself, where you want to enable this process that's using model-based definition. So I just say you'll see this workflow in different formats throughout the day-to-day, and sometimes together. Any questions on this workflow? This is kind of the crux of the whole thing here. This is what we're going to talk about, this workflow. So here's an example of a workflow. Okay, so the colors match up. This is what you do down here. Okay, and the colors match up to this workflow relative to how all that information is in the QIF file or in the model So the first thing you do is identify your measurement tasks, the below characteristics. That's embedded in the QIF plans and the QIF file. Okay, and there's software that puts that into you don't have to code a QIF file. There's a software that creates a QIF file based on the below characteristics. So you'll learn some of those software tools that we have that make this stuff easy. So the green part is you're assigning the measurement resources. What and how do I do? And that's the measurement plan in the inspection program. Okay, the DMIS or the QIF file that's used to create the inspection program. That's your green part. And then you have results that come out. Okay, that's the blue part. And then you want to analyze those results because, like Greg said, why do we get results? Typically 2 reasons: to determine good or bad, or to provide feedback into making something better. So that's the analyze. Do I analyze it to understand how to pass parts more often, or do I analyze it to fix the manufacturing process or design pattern? Okay, that's the analysis part. So like I said, QIF is kind of that file-based, it's rich data that's in an XML format that most people wouldn't be able to understand, but machines understand it, software understands it, okay? But really what you guys care about is the model-based enterprise. So when that model has that information, how can I use it? How do I make my life easier? How do I make it so that it's better quality or more efficient? That's really model-based enterprise versus QIF. They're doing the same thing. They're using rich information in a model to make life easier for us, but it's just terminology. So don't be intimidated by QIF. You don't really have to know that, but you do have to know that the model is where that resides, and I can enrich in my model somehow and make things more efficient. So why do you think, knowing all this, why would somebody use and adopt model-based enterprise in their organization? I'd ask that question, but it's in bullets right in front of you, so everybody knows the answer already. So there's a term called the digital authority model. In some companies, the definition of a part resides on a print. Probably most of you guys. And you have a model that is used to know how to manufacture or whatever. In some companies, that definition, the digital authority model, it resides in the model, and you don't have a print. Okay, and that's really when you get to that point, that's when you can start to use that information for other parts of the process. So you have one digital authority. The model is your golden piece of information. Everybody uses that to know how to do things. All of the requirements in one location, right in the model, right in the file. That's the definition of the model. It saves time because now I can use that and I don't have to duplicate it in downstream processes. It saves efficiencies. It improves quality. No misinterpretations, no quality errors. So that's all reasons why you would want to use the model-based enterprise. I think most people can relate to the efficiencies part of it more than anything. Because I have this information, I don't have to do manual processes anymore. So that's really the biggest benefit, I think. So here's a case study that's based on real customer information. So here we import a model, and this is without model-based enterprise. Okay, so we import a model. We can still use a model, and like Keith said, most 90%, I think 95%, you said, of people that are programming inspection machines use a model to assist them. Okay, but entering the GD&T information and the sequence of how you measure it and all that stuff is what the programmer's doing, and it takes time. I mean, it's kind of the bottleneck. Keith identified it as the bottleneck in their inspection services area. The time it takes to program a machine is kind of the long part of the task. So when you don't have that information, you're entering that manually, and then you measure it. The inspection part of it, the execution of it, is probably about the same. There's some efficiencies actually gained, but not much. And then the evaluation is also an opportunity for increased throughput and less time spent. So let's look at this now. So here you can see the big bulk of the process to create a program and get a data out was the GD&T entry, 61% of the time. And when you introduce model-based enterprise, you can see this workflow gets much simplified because I don't have parts of the process. I can just skip them. So I don't have to enter GD&T information. The evaluation of the results is more efficient, and so you end up being 60% more efficient in this particular case. Of course, it depends on how complicated the part is, or what kind of machine you're using. All of those are influences, but you can get an idea of the amount of improvement you can expect. So let's talk about adoption for a little bit. This is kind of why you're here. You know, some of you know about this, some of you use it, some of you don't use it. And adoption is really the hard part. It's this part, it's what you're doing today. You're educating yourselves to know how can I use this, or what, should I use it? Will it make our company better? That kind of stuff. And when you talk about, this is based on real data. There was a research study done based on how companies are using digital transformation within their organizations. And so they broke it down into these different areas. You know, engineering drawings, making them digital. That's one aspect of digital transformation. And you can see that's probably, most people have electronic versions of their drawings now. Design tooling and fixtures, generating tool paths for manufacturing, 50%. Authoring manufacturing documentation. This is more like process, how to do things, and digitizing that. That's 53%. The latter two are really more in the quality area relative to digital transformation, generating CMM paths automatically with digital information. This is what I've just been explaining, all this stuff. The digital thread enables that. Not too many people are using that, and the reports, the analysis side of it, there's, you know, not too many people are using that. So that's the potential for growth, and efficiencies in organizations are really more in the quality area than in the first part of the manufacturing process. Thought that was interesting, based on real data. If you're going to pay attention to anything in my presentation, it's this slide, I think, and probably that workflow slide. Okay, this is an important aspect to engaging in model-based enterprise. There's different levels, and I want each of you to think about which level your organization is in relative to this process. Okay, so level 0, this is the ultimate goal. This is this model-based enterprise concept that we want to get to, okay? And the level 0 is where we start, and you're probably somewhere in between, okay? But level 0 is 2D drawings only. There's no model. You don't have a model for the part, okay? Anybody have that? Examples of that? Okay. Not uncommon. Probably more common is level 1, where you have a 2D drawing and you do have a model. Who's in that? Okay. That's pretty common right now. And you know, you have a drawing, you're using the drawing, a CMM programmer is looking at a drawing when he's programming the part. He might have a model that he's using to help facilitate that, but it's a combination of the two. But the model isn't the defining factor, it's the print. Okay. And then level 2 is 2D drawings with derivatives from a 3D model. So the 3D model still isn't the authority, it's not the definition, but I can use some of that information for certain things. So there is some information in the model that I can use, but I still have to check it against the print. Make sure that when I use that information, it maps to the print, and the print is the goal of seeing. Okay. Some of you are probably in that level also. Level 3 is the start of what we're talking about in the seminar. This is using PMI information and using it for downstream processes. The difference between level 3 and 4 is that in level 3, the print is still the definition, but the model has all of that same information, so it's duplicated into the model, and I can use that in the model to create a program or whatever. Right? In level 4, that's when you switch from the print is no longer the authority. I can throw it in the trash. The model is the authority, and I can create prints from my model, but the model is the definition of everything about that part. You guys following me? Okay. Level 5 is when that model is actually revision controlled and is the trusted definition of your product. It's used across multiple types of disciplines, quality, manufacturing, packaging, blah, blah, blah. And level 6 is when that model is used to communicate to other devices or other partners, or a supplier versus different partners in the whole manufacturing stream, or maybe different factories. So that's the enterprise level. That's the thing that's in my title. That's the hard part is connecting the world to each other to be able to enable this kind of work. Make sense to you? Did you figure out where you're at in this? Way to figure out? So here's another research study. What are the hurdles that need to be overcome to make this transformation? Okay, most people say it's the complexity of integrating systems to each other. Makes sense. That is hard. That's why I'm here, so that we can develop products and services to help you through that, and education like you're doing today. Lack of human resources. They don't have the people, either because they're not qualified, or don't have enough people, or the people are just, dedicated to something else. Those are the biggest two hurdles, and maybe it's too early in the cycle. You don't feel like it's far enough along for you to be able to use it. Very valid. There's lots of things you'll learn, lots of things that we are doing now that make things efficient, but we don't have this whole workflow worked out. Some of them, there's some roadblocks in there, so where vendors like us are trying to work through them. Yeah.
Actually, a question. I apologize about the last slide.
No, yeah.
I was curious about, we were talking about the level, so we're I think at a level 2, but I was curious, with the level 3, wouldn't you want to have the hard copy as well, kind of like level 2? I was just wondering if you ever encounter really a lot of people who are just going strictly to 3D modeling.
Yeah.
Is that just like the norm now? And if so, what would be the risk involved in that?
Yeah, so if you have a model that's defining your part, and then you, from the model in the CAD system, you can do a 2D view, print out, a drawing from a model, and that's a pretty common scenario. I print that out and I use that. Sometimes that makes things easier if you're still doing manual entry. The model is the definition, and you know that what I printed out from the model is true because it came from the model. And then I can go ahead and create a CMM program, for example, by looking at that print. So that's an example of that.
Oh.
But what's the risk in doing that?
Well,
I mean, what would be the problem in doing that if the model is the definition and I'm printing it out and inserting stuff in?
well, I was thinking more along the lines of, I guess when you're making changes to the models, customers making changes to the models, having current, I guess, up-to-date models.
Very good point.
And that's where I was wondering about the risks as far as, I mean, granted, you could probably have the same risk with doing hard copy prints as well, but I was just wondering, that's kind of why I was wondering the difference in the two, between level 2 and level 3, and if people are going to level 3, like I said, just kind of curious if the risks are at the same level of having an outdated model.
Yeah. Well, there's the potential of using an outdated model is potential of using an outdated hard copy also.
Okay.
Some of your organizations are probably ISO certified, right? And when you have a process or something, and you have a printed out document of the process, it is not the authority. So if you want a current document, you don't really need to go on your document management system to get the current version. Similar scenario here. You always want to go to whatever's controlling your revision control, where in the case of level 3, it's revision control on the model. In the case of level 2, it's revision control on the PDF print. And that's the control part of it. Okay. And then it's the organization's responsibility to make sure that the people are using the right version.
Right.
And that's the revision control and stuff like that. So, good question.
From my experience, usually in the MPD, it's embedded, like the revision is embedded.
Yeah. In the model.
Kind of the same.
Yeah. So if you do that in level 3 and you print a hard copy of the print and you're using that, one of the risks in doing that is the translation of the print to whatever you're using for the print.
Right.
So in the case of programming a measurement machine, it could potentially enter that wrong, or it could do the sequence incorrectly to where it's going to give me bad results. And so when you use that model that has the information and you have a smart enough machine or software that's going to use it in the right way, then you reduce that risk. Quality problems.
Right.
Maybe one of the things that might help some of you here is, how many of you actually trust the model right now? Can I see show hands? You should be lowering your hands.
Yeah.
There's problems here between the drawing and the model. How many can relate to the fact that the model has different dimensions than the drawing has? Like one on enough digits or they're rounding, et cetera, right? There's simple things like that. The other thing is, how many have drawings that don't have some of the dimensions that they refer, you gotta get them from the model.
Yeah.
So you're already kind of between the 2 and 3. The problem is you're trusting the 2 to get to the 3, right?
Yeah.
So the validated piece up there is that you gotta go through some validation. I know some of you are, but most of you are in that trusting mode right now, and it's getting you in trouble. You usually find it after the part's been inspected, and you're rejecting them, that there's a disconnect.
Yeah.
Right?
It's dangerous to go between level 2 and 3. You want to make sure that you're at level 2 or level 3. If you're in between, it's dangerous because you don't know what is the authority, what is the truth.
Well, that's kind of why.
Show me the truth.
Right. Well, that's kind of why I asked the risk on that. Like, where you know, is there any difference, I guess, in risk?
Right.
Is there, just trusting a model based off the model itself?
Well, I'm biased, but level 3 is much less risk because you have it's all embedded and it's consumed automatically. You don't have
At level 3,
all of this. The more right you get, the less risk you have because it's all theoretically it's all automated and connected.
but at level 3, you're not implying that there's no drawing involved. You're just saying the drawing is kind of beneficial because, I mean, like
Yeah.
in my case, we have our models that drive our drawings,
Mhm.
so all the information is stored in the model.
Yep, that's
But
level
we
3. Yep.
Leverage the drawing
Yep.
for, display whatever the tolerance is,
Yeah.
be able to check it,
Yep.
verify.
Mhm.
But that drawing is a portion of that piece.
Right.
Because it's kind of hard to look at a 3D model
Yeah.
and see the.
The drawing is helpful in human interpretation, right? Yeah. No, that's a very good point. Level 3 is not intended to be no print. A print created from the model, now you can trust the print, to be accurate to the model. But it's still useful to have. In these other worlds, level 4 and 5, because I'm not even doing anything, as a person, I'm not looking at the print to do anything on my machine. The machine's just reading it. That's when you don't need it. That's the difference. So in these other scenarios over here, theoretically, you don't need to print it because a human isn't going to be entering in GD&T tolerances, and they are not going to create a program. It's going to be done automatically.
It'd be the same way for manufacturing.
Yeah.
For the machining part, it would just be put it in your machine and it's going to cut it for you.
Yeah, exactly.
I think one of the key things that would have to be at level 3 is that you don't have any rounded dimensions. Model dimensions is perfect compared to what is actually being displayed in the drawing.
Mm-hmm.
And so you don't have rounded dimensions on there quite all and match to match.
Mm-hmm. Yeah. Yeah. Because you're bringing digital information out of the model and using it, you have less susceptibility to those kinds of problems. Good questions. You're starting to get it. Good. And you're starting to understand the issues with this. I mean, it's not issue free here. There's a lot of work to be done to get here, and there are roadblocks. There are yeah. What? It's hard. Yeah. This is more information, relative to how, going into digital is who's using this for more than others. So OEMs versus suppliers versus aftermarket kind of people. OEMs are really the ones that are pushing this, so the ones that are providing the end product, because they see the most gains from it. They're reducing costs, they're reducing quality issues, they're making things more efficient. So that's who's driving it, and this is real data also. So a tier 1 or tier 2 supplier is not as, they don't see the benefits as much. They're making parts for the OEMs, but I think that'll feed down as this becomes more and more of a reality. So in general, this was their summary in this research study, is that there's very little understanding what digital manufacturing actually means. A lot of people don't really understand what that means. Does it mean making everything electronic? Yes. Does it mean using electronic and digital information for machines? Yes. It's the answer to all that is typically yes. There's a lot related to that, and a lot of people said that they're translating or recreating their CAD models and using that for downstream processes, and that's fraught with error because if you're creating duplicates that might be misinterpreted or incorrectly identified or whatever, that's problematic. And so that's what this whole thing tries to get rid of, is duplicate kinds of ancillary models that you're using. 91% use email to exchange tech data, so the data fidelity is gone. The digital thread, if it's in a database that is on a network somewhere that machines can communicate to, can retrieve and provide feedback on, that's when you avoid these manual data interactions. So we all use data in our daily lives, but it is typically manually interacted with. You send an email to me, send this Excel file that has this information, and I have this Word document, and I have a model, and it's all disparate. So this reduces that. Little sense of global use of manufacturing digitization. Why do you think that and this was, I think, 2020 data. So Asia has adopted this more than Europe and North America. Why do you think that is?
Labor, overseas manufacturing, pushed out. We've all seen that.
Yes, it's pretty obvious why this happened. Now, thankfully, I guess, depending on your perspective, a lot of the manufacturing that was done in China is coming back to the U.S. And I think I was talking to Matt about this when we were walking through all the robots. When manufacturing, when that does come back here, and we start to recognize that there's opportunities for better quality or more efficiency, and now even lower costs, that this will drastically change. I think the U.S. will adopt this very rapidly now, and it's just inevitable that you guys are going to have to deal with it one way or the other, because what we'll do as Americans, I think, is try to make things as automated as possible. And that's really what model-based enterprise allows you to do. Do it as efficiently as possible, do it with minimal quality, and make it so that it's very automated and machines are talking to each other. So I think this will shift in the coming years.
Do you think with all the automation, though, do you think eventually we would see jobs become obsolete?
I don't think so. My theory on that is that a job like say in the quality sector, because now it's a program is created automatically, that person is going to be doing a similar role, but instead of wasting time, you know, doing a manual entry of GD&T information, for instance. They're doing higher level tasks like, you know, understanding how that quality information is going to make the manufacturing better. So that person is now just going to have an elevated job that's more useful.
The only reason I asked was I was actually just talking to him about this earlier, where the other thing that Jim Sturz was working on was being able to check inspection within the actual lathe itself and be able to make adjustments automatically on its own to reflect it. Yeah. And so when I thought about that, I thought, well, if you know, if you have that, what would be the necessary need for somebody to check that? If the machine's already going, well, I already know where to put this, so we scrap out one part because we may have made some bad moves here, but I know how to adjust it to make the more perfect part. So I guess the question is, like I said, where does that become, you know, where it's like, okay, well, we still need more and more people. It kind of almost feels like you're losing more people when you start doing that.
Yeah, well, when you talk about inline and offline inspection, that's really dependent on, you know, what you're manufacturing, whether that's possible or not. It's usually about accuracy or size, or, you know, how you need to inspect it, is whether that makes sense. But I think the same applies relative to jobs. You know, there is that person that was typically, you know, hitting go on the machine tool to make a part is now, you know, trying to understand the data coming from it and interpreting it for other downstream processes. You know? So it's just, again, I don't know. Any other opinions on that?
We're all looking for more people, right? We're low on people.
Yeah.
So the quicker we can get things done,
yeah,
those people can fulfill those jobs.
Exactly. Yeah. Yeah. There's the labor shortage is very evident. So I talked a lot about adoption because I want you to realize that not everybody's doing this, but it's probably good to really, you know, educate yourself about it, start to engage in it, and, you know, start to use companies like AAS to use as a model for how you might implement it within your organization. Because that's really what these guys have done. They've implemented this, one, because it makes them more efficient, but two, because now they can communicate to you how they can help you, you know, enable this within your organizations. But this is a quote from Machiavelli back in 1500s, before there was any manufacturing process. It's about change. So this is change. Moving into model-based enterprise is a change. There's nothing more difficult to plan, more doubtful of success, nor more dangerous to manage than the creation of a new system. Model-based enterprise, a new system, enabling this digitization. For the initiative has the enmity of all who would profit by the preservation of the old system. I want to keep doing it the old way, it's easy. And merely lukewarm defenders and those who would gain by the new one. That's me, I'm a defender of model-based enterprise, that's what I do, it's my job. But, you know, you as within your organizations, you need to understand what is the game. And that's what we're here to educate you on. Why would you want to do this? Is it going to be easier, cheaper, better, faster? All those things, the answer is yes. So this is some of the organizations that we work with relative to this whole enterprise. But DMSC is really who created the QIF standard. Digital Metrology Standards Consortium, it's a government facility that is defining this. They're getting input from customers, from vendors, from other standards like the GD&T standard. So it's really a good group that's creating this. CatVidia, Lyle Fisher's from CatVidia, they're very embedded in model-based enterprise, heavily involved in the QIF standard, and you know, are experts in the translation of CAD to QIF and CAD to usable information downstream. So that's kind of their focus. There's companies like Calypso, not to be confused with Zeiss Calypso software, but this is an integration house. There's lots of integration houses where they're taking, you know, they might have CAD expertise, and they're using that to, you know, try to figure out how the CAD models can be used in other processes, and Calypso's really trying to engage in that. There's companies like MXD, they're in Chicago, and they have projects that you as customers, we as vendors can engage in, where they fund a project and help you through a project, and you can, you know, provide, you know, the project to them that you have that you want to try to solve, or you can engage with them to be part of the project. So, and they have mega government funding from our government, and then MTC is the same story in Europe. They have huge government funding, and the purpose of both of those organizations are to make our manufacturing in the U.S. better, more efficient, easier, cheaper, all that stuff. So that's a good organization to look into. You should go to their website. They have a cool virtual tour of their facility where they show how Industry 4.0 and model-based enterprise is really used in the real world. All right, here's my pitch. These are our products. This is that workflow that I was talking about, okay? If you remember the QIF workflow, this is that workflow in terms of products, my products. There's other people, other companies that provide similar products, but we're trying to close the loop on this whole system by providing software products in every step of those, of the QIF workflow. So you can see the design is the first part of it. That's where an engineer, you know, a designer is really defining things. We've developed a product called Evolve Design that can do primarily one of two things: either allow an engineer to enter in GD&T information from scratch if they don't want to do it in a CAD system, because it's a lot easier to do in this product. I know that from what customers have told me. And so they might just populate the model with PMI information, GD&T information, right, in design instead of their CAD system. The other scenario is that they put GD&T in their CAD system, and so now they have a rich model, but the CAD system doesn't really know GD&T very well, and so design is a proofing software where I can bring in a PMI rich model, and it'll tell you it has the GD&T standard embedded in the product. So it can look at and interpret that model and the GD&T callouts on it and say, this callout isn't right, you don't have the right datum definition, or this is not possible because, you know, it's an MMC versus LMC. You know, it gives you all these rules and it says, this is a problem you need to fix. And then there's also warnings. These are potential problems that you should be aware of. And then there's considerations or recommendations. These are recommendations for how you can do this better. So one of our customers calls this the spell check of GD&T. It's like when you have a Word document and you have the spell check. Everybody relies on spell check now. That's what this is for GD&T. Thank you, Andrew.
Is this specifically just GD&T? Does it take into account any other industry standards? So like you're talking casting standards versus machine standards, general tolerances, and all of those?
Yeah, so there's in the manufacturing side of things, there's also a foundry module for castings, and it is we map the GD&T callouts, you know, which are really a Pascal kind of criteria, to, you know, how you manufacture a part, which are different data structures. You have different operations for how to manufacture a part, or castings are different, you know. So the manufacturing module and the foundry module kind of take that Pascal information and say, okay, how do you feed that back into, you know, how you manufacture it, and what can I tweak to make the process better? So we don't really, you know, apply the standards in those industries, but the feedback mechanism into it is there. The other thing, I'll go into each product a little bit more in a second, but the workflow. So now I have that design, and I've validated that it's correct, okay? And not only does that validate GD&T, but it also helps validate some of the semantics on it. So one example of a semantic problem is in a CAD model, a designer might point to a bolt hole pattern that has 5 holes on it, right? And they point to one of the cylinders and say, each of these diameters have a diameter tolerance or precision tolerance on it. But when you bring that, when that's read into another software package, it might see that that tolerance is connected to that one cylinder, but it's not pointing at the other 4 cylinders because the CAD designer didn't do that. So we recognize that because it has a 5x next to it, we should look at other similar cylinders and apply that same tolerance to those. So it does some of that stuff too. But anyway, now that you have semantics correct and you have GD&T correct, I can start to use that for downstream operations. So I can actually open that model in Zone 3, which is our measurement package that controls machines, and I have a program that says how to measure it. I call it reverse programming. So the means of programming an automated machine used to be, okay, let me measure this cylinder, measure this plane, measure this surface, and I do that, you know, with touch probes or lasers or video measuring machines, and then I say, okay, now that I measured those things, I'm gonna add a GD&T tolerance to them, click on that cylinder and do a form tolerance on it or whatever. Okay. Backwards programming is saying, what are the requirements? What's the bill of characteristics that's defined in my model-based file? I have a list of 10 GD&T callouts. Okay, so from those callouts, I know that I need to measure these features and these datums. So all I say is, measure this GD&T callout, and it knows exactly what to measure and creates a routine for it. Okay. So that's the measurement part of it down here. You can bring that into different kinds of machines to do the measurement. The measurement software sometimes does reports out information right from the software. SmartProfile is another means of evaluation. Okay, this is a agnostic software where you can bring in a point cloud from any machine and evaluate it the same way, independent of what machine it came from or whatever. This is the same thing as design, so it's all very GD&T perfect. It's, you know, we've complied to the standard without compromise. And so the idea of using SmartProfile instead of the inspection machine software is that you're using the same one across all different inspection machines across all factories, so you're getting the same answers, and it's always correct. You don't have to worry about misinterpretation. That data can then go into SPC for historical archiving. The difference between this SPC and other SPC packages is that it's model-based. The QIF model is in there. So when I do stats, I click on that feature on the model, the visual representation of the model. I know I can look at the historical information, or I can look at the image in Zone 3 of how that was measured with the actual data points on it. All of it's connected. And then the feedback. Once I have that information about whether it's pass or fail, I can bring that into manufacturing and say, okay, don't evaluate it on the GD&T definition of datums. Evaluate that same thing based on the operations I've used to manufacture the part. And so now tell me how to change the offsets or change the tooling or whatever to make that correct. And I can do what if scenarios and say, if I made this change, based on the process control, how would it affect my results, and can do it until it passes, and then when I make that change, that's going to be a positive result in the outcome on my parts. So that's the workflow with a product. What products can help you through the workflow?
Question.
Yep.
What if you don't own the design, so your contract manufacturer?
Then you buy it. You gotta buy it.
Perfect. It's always the answer, right?
If you don't own design module.
Well, I'm saying, what if you don't own the actual design? So I'm a contract manufacturer. my contract manufacturer uses 2D, or my supplier, or the person I supply has a 2D drawing, and they have a step file. But I, as the contract manufacturer, would like to use an MBD.
Yeah, good question.
How do we bridge that gap, or?
It's a very common scenario, actually, and part of the reason why we did the design module, because if you get a model from your supplier and it doesn't have that information in it, it's very easy to put that information in it if you want to be more efficient in your operations. And that's so you can use the design module to bring the model in, put the PMI information in, and now, and the output of that is a QIF file. Now that I can use for any machine that I want to inspect with. So,
or even a service to sell to your customer.
Yeah, yeah. You could provide it back to them in QIF format and say, here's now your model enriched. Yeah.
We'll step you through that here on some of our next steps here, because it's a common scenario we see in AIS. We got the print better model. We'd like to have those combined for efficiencies on our end, just like manufacturers.
Talk with authority.
Got it. Talk about her next time.
So do you in turn then sell that as a service? Is that a product then that you sell back to them, or you're just saying, hey, we did this for you, it's just something nice we did, or?
Lots of people aren't interested right now.
Okay, they're just like, okay, whatever.
Yeah,
Good for you.
But it's certainly something that we can return to the customer. We can pass interacting projects if they have some of these evolved products that we use often, but it's definitely something you can pass back to them.
So just a little bit on each of those touch points. The design module, like I said, it's used for proofing GD&T. It's used for populating models that don't have GD&T, populating to enrich them. It's used for tolerance stack-up. You can simulate inspections by creating points on the model with variation, so that you, even if the part doesn't exist yet, it's just in the model format, you can have all this done, and even try to understand what kind of variation problems you might have, because I can create fake points on the part. I don't have to inspect the part. I can simulate it. And then once you do that, you can export it as a QIF file so that you can use it or have it for a supplier. You can populate measurement strategies in design. So when this is connected to Zone 3, our measurement software, it looks at the measurement strategies, how to measure certain types of features, and it lists them available in here for, say, I want to measure this cylinder this way with this measurement strategy. Okay, and so one thing that when you talk about jobs or what people are doing in this scenario is that instead of programming a sequence and defining how to measure, measure things, you might be defining what is the best way to measure a feature of a certain type globally. So across 100 parts that I have, whenever you measure a cylinder, do it with this touch probe with this many points. That's a measurement strategy that can be applied globally to multiple part types.
So let's say, for instance, we have a CMM where we don't have a tip changer or something like that. We only want to use one tip, and there's, so a lot of times we use that one tip across all of it. Would this automatically try and put different tips on there for ideal measurement?
It doesn't optimize the sensor for the part yet. That's something we want to do. That's the intelligence part of it. But what it does do is it says, the programmer has defined that planes or cylinders need to be measured with this tip, and planes that are horizontal and hidden need to be measured with a right angle tip, kind of thing. Those kinds of rules can be applied so that when I bring it into my my measurement inspection software, it applies all of those strategies for me.
So how long are these measurement programs? Do they end up being quite a bit longer than your normal one would be, or are they optimized?
They're probably the same. I mean, they're still measuring the same amount of features, so the length is correct, but the sequence is optimized because it knows all the prerequisites to the GD2 tolerances. So it does it in the right sequence, and then it can be optimized for flow also.
And a lot of what we're talking about here is gaining time on developing your programs and getting to the point where you can put your part on your machine and start the actual inspection. This isn't going to cut the actual like CMM time in half. It's just getting to the point where you have an efficient program to make those measurements and a significantly more faster path. So you don't have an engineer sitting there spending 5 hours writing a program. We can write a program in 5 minutes, validate, test it quick, and then we're right onto a CMM doing the inspection. So that's where a lot of this is going, is the implementing faster turnaround time to get that part on the machine quicker.
So that's the measurement strategy. Within design, there's a button in here where I can hit a button, and it just brings this project that is now validated into Zone 3, and I have a program where I can run it. That's the cool part of this whole thing. CAD bridge is cool. So right now we only work with Creo on the CAD bridge, but the idea is that you have a bidirectional communication to the CAD authority. Remember I was talking about that before? The CAD package is usually where the definition resides, and that's the golden standard. And so you can communicate, once I fix things here, I can backfeed that into the CAD package so that now I have an updated model that's correct. So we have a CAD bridge that can communicate directly. SmartProfile is the evaluation software. So now I can drop data point clouds onto it and do the evaluation. This is my bill of characteristics over here. It tells me whether I pass or fail. Okay. So it's really the same as design, but it's now doing the analysis and reporting good and bad. Manufacturing is what I was talking about relative to feedback. So once I have good, bad criteria in SmartProfile, I can use that to understand how to fix my problem. So, you know, I can do component analysis based on whether the location, orientation, size, form is the problem area, and then fix it accordingly to that. Set up different, instead of setting up datums, I'm setting up machine operations where the fixtures are the constraining devices, and knowing how and what I can change to affect my design results. That's what manufacturing is doing for you. And the SPC is like any SPC package. It's got real-time charts, it's got historical plots, but the difference is it's CAD-based, and it's all of those connections to the CAD features are connected, and the data is connected back to the model. Zone 3 in our world this is what controls machines in the OGP world. So whether it's a CMM, a multi-sensor machine, a video measuring machine, that's what controls our software. So when we create a program in Zone 3, we're measuring this part. So this is the model. All the GD&T comes in with it, creates the program in a sequence according to that, so that I can measure the part in there and run the machine. This is also available for an I++ client. So what that means is that not only can this control an OGP machine, but if you find that this whole workflow is useful, and I like creating automatic routines from a model-based enterprise, and I want to run my other CMM with it, I can do that via I++. Actually, I have an example of that real quick. So here, this is connected via I++. Oh, it's not showing. Yeah. So this is a CMM that isn't an ODP machine, and it's running Zone 3, and really I just connected to it via an I++ connection. So going back to standards, I++ is another standard that allows machines and software to communicate to each other. So I can create an automatic program in zone 3 and run a different type of machine.
I'll talk while you eat, so be very efficient here. And again, so we've taken everything that Tom kind of presented and made the process flow that works for us. And so it's one of thousands. And so this kind of fits what we do. And, you know, who knows right, who knows wrong, who knows best. But this kind of looking at how we do our work, what our customers want, kind of led to this. And so again, as we start, you know, again, 1,000 jobs a year, maybe, you know, 4 or 5 new jobs every day coming in. And a bunch of information comes with that, and the first one to run into it is Jake or Chris or Skylar. And so they would interface with the customer, and they talk to them on the front end and, you know, give them a proposal for what they got to do, and we try to make sure we understand how they want their data presented, and we say, okay, do it. And so we'll get a PO and we start working. Now, working for us sometimes is somebody say, okay, I need these CT scan, I'm concerned about porosity. Or I want just the RZ surface finish value on these 30 parts. We don't go down the QIF path with any of that. We've got a PDF, we've got some set of instructions, and we just go about our business. And so that kind of gets us to here, and we say, well, is this CAD-based? Do we have some kind of a 3D model? And if the answer is no, we just go about our business. We scan it, surface finish, form, whatever else. But if we do have a 3D model, the current question is, well, what kind of a model? And for us, that's probably 95% of the time Tom's description of level 2. So we're getting a 3-step in most cases, and we're getting a PDF print, and that is our source to go forward. Now, of late, not too frequently, but sometimes we will get some kind of a model definition format from our customers. And a lot of times it's QIF, sometimes it's something else, but we kind of work our way through it to get into the model-based definition kind of world. And so, whichever it is, we start and SmartProfile, as Tom was really, it is Evolve SmartProfile Design. Evolve SmartProfile Design, which now has been kind of shortened to design. I just didn't get my slide edited in time. So if somebody comes to us and they say, here's a QIF file. Oh, good, it's a QIF file, and we know that this is a contact CMM job. It's going to run on a hexagon system with PC-DMIS. Boom, we can go right there and be done with this. But what we do is say, well, wait a minute here. You know, I want to make sure we really understand this, so we will take QIF and we would just start in design to do what Tom described on the GD&T checking. And the other thing is, you know, our customer has certain expectations, maybe naming conventions or sequencing, and maybe that's not represented quite right in the model-based design data that we have. By stopping in design, we can validate the GD&T and make sure that, hey, I think everything is right, they're going to be happy with this. Now on the other end of things, if all we get is a nominal file, a step file, and we say, well, okay, now in design, I am going to take my PDF print or whatever else I have, and I'm going to embed my GD&T into the design project, and then I'm going to do that same GD&T validation, and then I'm still going to verify that my labels are all correct. So one way or another, whichever way we get, right out of here we come up, maybe we say, hey, it's a validated QIF for our purposes. Now, a neat thing about design that Tom talked on just briefly is that in design, we can generate measured points. Now, in the whole end, I'm going to go to PC-DMIS and a CMM. I'm going to go to Zone 3 and a vision system. I'm going to go to a CT scanner. I need to get measured points. I haven't done any of that stuff yet. But it sure would be nice to be able to show the customer what the final result is going to look like. And so a nice thing about design is the ability to generate points. Perfect points or points with just some arbitrary error in them. And so that's what we would do next. Say, okay, I'm going to take my validated project, I'm going to generate some points, and I'm just going to go test my reporting. And so all those formats are kind of developed, and now I can come back to here and say, okay, there's my test points. They're all perfect, or they've got some kind of set error in it. And in the other end comes back, here's the report. And the beauty of this is that now we can go back to our customer and say, well, hey, you know, we haven't started programming this thing. We haven't put a lot of time into this, but here is what your report is going to look like. Here is an Excel file, here is a graphic report, here's a data file, and so we can simulate exactly what the customer is going to get in the final analysis, and so the customer can then say, oh, that's not what I thought I was going to get. I thought I was going to get it this way. I hope to get it that way. So we can verify that, yes, when we are all done, you're going to be happy with the format of your data. And so check, that looks good. So check, that looks good. And now I can say, okay, now I got to actually measure these things. How am I going to do this? And for us right now, our primary solution paths, a hexagon CMM with PC-DMIS, a multi-sensor vision system from OGP using Zone 3, or in this case maybe a CT or a structured light scanner or a laser scanner or some kind of a mass point device. And so that is where we are actually going to go get our answers. And so, well, how do I get that? Well, we write a PC-DMIS program, we make a Zone 3 program, we make our CT program and all our parameters. And you know, the perspective from us here is that these guys, John, Jim, and Mike, they are a very valuable commodity around here. Their time is at a premium, and I think you guys all know finding experienced, expert programmers ain't easy to find, so we want to do whatever we can to make them more efficient. And so they get the data, and then they write their program, and then when the program is done, they start to say, I better inspect the part. And they inspect the part and they go, oh, that's not right. That's not doing what I expected it to do. So they may have 1, 2, 3, 4, 5, whatever number of iterations till they say, yeah, I think this program's kind of stable. I think I've got what I need to inspect my parts. And so, you know, when you make these processes and flow charts, in our case, it's more going around and talking, okay, how do we do this now? And, you know, there's things that are not necessarily formalized, embedded in the process. So I just talk to the guys and say, well, hey, you know, when your program is done, how do you prove it out? And you know, we do contract inspection work. There's nothing we like better than the customer telling us, oh, I want a 10-3-3 GR&R study. So now all of a sudden we've tripled our budget from the customer to do all that work. But in most cases, they don't go for that. But we're not just going to say, well, you know, this machine's really accurate, everything's going to be fine, let's go. And so in our normal everyday check, we would say, I'm going to run it 5 times in the fixture. And then I'm going to run it 5 times in and out of the fixture. And I'm going to look at that data and kind of combine that with what I know about my machine capability and decide, am I a go or no go on that feature. So that's kind of what this is. They say, okay, I've got a working program. It's running around doing what it wants. And I'm going to send out these test points. And it's going to go down here somewhere and turn into answers. And now it's going to come back in here as gauge test results. And so then we can make a decision on how we say, yes, it's good to go, or no, I got 12 features and this feature is really got a problem. What do I have to do? Do I have to change my program? Do I have to change my fixturing? Do I have to maybe go to a different machine? But basically, we're trying to make a quick, good decision that, yes, we have a program that we have confidence in. Good. So that says now, if I've got 50 parts, I'm going to start measuring my 50 parts on the CMM, on the multi-sensor, on the CT system. And finally, what we're trying to get here is I actually have measured points. Now, in our case, because we had that design project in the first place, that had all the GD&T embedded in it. And now, not design, but just SmartProfile, it does the analysis for us. And in some cases, our number one and maybe number two best customer has said, okay, well, you're going to use a Hexagon Global. You're going to use an OGP Smart Scope. You're going to use a CT system. But all of the data is going to come from, all the data is going to be analyzed in SmartProfile. And sometimes that customer will say, hey, here's the project, it's ready to go. Other times we're going to do what we're going to show a little bit is, hey, we got to append the GD&T onto our model. But all of these points flow back into SmartProfile for analysis. Now, when we first had customers asking this, these guys would say, oh, what a pain in the butt. You know, I got to write this program, and then I have to file export points, and I have to file import points, and I got to do all this other stuff. That's going to add another 40–50% to my time to get this done. And so working with customers and for our own needs through Adam, we made like a point server. So we know that as soon as I make that design project, I can put it up in the server, and then this thing is just saying, hey, I'm the analysis engine for part ABC. Where are my points? And it's just waiting. Are the points here yet? Are the points here yet? Are the points here yet? All of a sudden now, the points flow in, and our design project says, oh, there's the points. Do the analysis, and then I need this graphic representation. I need these answers. I need this kind of an Excel report. I need the standard AIS report. But all of this is kind of automated, so that makes this a more efficient kind of way to go. So here's how we process the points, and what we saw is the first thing, hey, I just want to simulate my report. Oh, okay, so we bring in these artificially generated points, we do our stuff, and then send it back and say, here's a report. And then after that, we said, okay, I've ran my first 10 parts. I want to do my gauge test, so in those points go, and out comes the gauge test results. But the reality of the situation, once we say this is okay and this is okay, is now I actually am measuring points and inspecting parts. And that gets us to say, oh, what are we going to do now? And so there's a big packet of data. In our case, it kind of ends up in two different locations. We've got kind of a file that we build right from the front end. The customer says, here's my PDF data, here's my instructions, here's my model. And then our kind of point server says, okay, I'm going to save every set of points. I'm going to save every project. I'm going to save every analysis. I'm going to save all my image kinds of things over here. And at the same time, I'm also going to ship the data out to a SQL database if I need to do some SPC kinds of things. So, and this is our reporting, which is kind of meets our needs. Now, we don't make these things. And so we're not feeding points back to manufacturing. We're giving our customer, hey, here's all the stuff you asked for. If you want the points, we'll give you the points. But we're not closing the loop back to manufacturing. We're not embedding it into the model. We're not trying to do automatic feedback to the machine. And so if we were interested in doing all that kind of stuff, then we would sign up more for the QIF side of things. I am not going to, you know, these are essentially the reporting things we've always done. We've just tried to automate it. But if we were a manufacturing outfit, say, hey, no, the digital thread, we got to get this stuff back embedded in the model, and then it's got to feed back to manufacturing, and it's automatically going to change offsets and do all that kind of stuff. That's what the next level of QIF implementation would look like. But for us, We're just trying to say, I got measured points out that I have confidence in, I have an accepted report format, declare victory. And so for us, what is that? Is that, well, the CMM guy, Mike, Jim, or John, would say, okay, I gotta look at this to make sure this is what I expect. So they would look at it and say, looks good to me, I'm gonna sign off on the cert. And then it goes back to Jake, Skylar, and Chris to say they've gotta present it to the customer and say, here are your results, any questions please. And hopefully there'll be minimal questions because we gave them the report in the first place so they knew exactly what they're gonna get, and now they get it. And so that is our kind of implementation of this. And you know, like a lot of new plans, we kind of did bits and pieces independently, just doing it on our own, and not necessarily proceduralized, not necessarily having everybody do it the same way. But as we start doing more of these, we need to get into that everybody does it the same way. And so that was kind of the theme of this, is that this is how we do it. We're trying to standardize it more and use it all the time. So I figured if they got to get up here and talk about it, they'll really be experts at it. And you know, and again, it works fine for us. And again, a lot of it was driven by our top customers saying, this is how you're going to do it. And so we comply with our customers, and then we kind of go, oh, these customers are right. They really got a good suggestion of how we should do this. We should spread this out to as many customers as we can. So that kind of turns into our standard approach to this. So that's the quick overview. And now we'll just do some brief demos to say, well, how do we get there? And so we'll say, okay, this is CAD based, and we'll talk a little bit about, you know, I have a QIF file right from the get-go. And we would stop here just to do the validation and to do the label verification. And again, this QIF file, our QIF file for the example here was something, it's the OGP demo part. And so we designed it up in SolidWorks. So we did all the GD&T in SolidWorks. We had the model, which was, I think, a step model in the first place from OGP. And good, we're all done in SolidWorks. So what are we going to do next? Well, we need QIF out. If I want a QIF file out of SolidWorks, we go talk to Lyle from Capvidia, and we use the Capvidia product because that gives us the ability from SolidWorks into QIF and then out along the path. And so we make just a quick stop in design to say, is the GD&T actually right? Because they're pretty thoughtful about it. And are the labels right? And can we make a test report? But in most cases, again, now for us, if we get a 3D model, way over 90% of the time, it's going to be a nominal file. It's going to be a step file. And we've got to append the GD&T. And so if we have to append the GD&T, here's how we kind of solve that. So Jake and Adam will kind of give you the quick overview of how we would do that.
Hi, so I'm Jake, and as Keith mentioned, I'm a sales engineer at AIS with Skylar and Chris, and we're also project managers, and we work with customers who need to have parts inspected, and we also oversee the whole workflow all the way until returning the data that the customer needs back to them. And I will be doing a brief demo of how we would prepare the data in design. So this is the print of that OGP demo part that Keith mentioned that I will be preparing the data for.
Are we okay, Greg? Greg Hetland approved, so we...
So if we don't have the QIF file right off the bat, we would just import the CAD model. So we have a step file for the part here. And the print says that this bottom surface is our datum A, so we'll go to dimensions and datums. Whoops, click the wrong surface. Just a little bit.
Yeah.
Yeah.
Yeah, there you go.
There we go. So we'll call that datum A. We'll click on datum, and this drop-down menu allows you to name it.
Yeah, a little louder.
Oh.
You're moving your mouse, that's why you.
Oh.
I
Moving
get
the
you.
mouse while we.
There we go. Okay, so we'll call this datum A. I also see that we have a flatness call out for this surface, so we'll go to GD&T tolerances, and we'll select flatness, and on the print it says 0.1, and we'll label this as dimension 1. Now we have everything set for our datum A, and this front surface is labeled as our datum B. We don't have to label the GD&T and datum separately. We can do them together. We just go straight to the GD&T tolerances. And for this face, we have a perpendicularity call out. And it'll bring you up to the datum drop-down menu, and we'll call this datum B. Also, it automatically assumes that this surface is a plane, but you can change that type here if necessary. We'll click OK, and that perpendicularity call out is 0.1. Reference to datum A. We'll call this dimension 2. And then our datum C is this left surface here, and another perpendicularity call out. Oops. Dragging the mouse.
Roll the model over, make sure the bottom's not.
All right. So we're good there. And this is our datum C. Click OK. Again, 0.1. This time it's referenced to datums A and B. This is our third dimension. And then our dimension, or our datum D, is this cylinder here. And I notice it has a position call out. And we'll call this datum D. And this feature of size here, this 25mm diameter, is its own characteristic. So this will be our dimension 4. And we have a plus or minus 0.05mm tolerance. And this position is 0.25. And we have a max material condition modifier. And then this icon gives a drop-down menu of all the suggested datum reference frames that we can use. And on the print, we have ABC here, so I'll click on that. And then we also have another tier here. So we'll click on this plus sign to get this bottom part. And on the print, it's 0, and it has a maximum condition modifier to datum A. And we'll call this our dim 5. And that's pretty much how we would build the.
So you're 20% of the way there. So we're 2 minutes in, and we're 20% of the way into taking it and defining our GD&T project here. So you can see it goes pretty quick, and a nice thing that it becomes the source for Zone 3, the source for PC-DMIS, the source for CT scanning. And so that's how our way to put that together. And we talked about the other nice thing of that once we have it done is that we can generate this set of test points to see that our reporting is right. Adam, are you just going to give a quick?
Yeah, we'll step to that in just a second. It's fast to set up, but if we have, 100 dimensions, 150 dimensions on a part, right, it starts to add up some time where the QIF can really be a time saver in our passing of information between different processes. Setting up 5, 10, 20 dimensions, not a big deal, pretty easy to do, pretty straightforward. Larger, complex parts really sees the benefit.
Does this all make sense so far? Cool. All right, and then let's say we do have a QIF file. We can just import that And we already have all the GD&T callouts on there and all the dimensions. And oftentimes the dimensions won't come labeled. We'll have to spend some time going in and numbering all of them, but it still saves us a whole lot if we have all the GD&T already in there. And on the left side of the screen here, we have this explanation column, and that allows us to, if we click on one of the GD&T callouts, it gives a brief description of what's going on in each, and then it also gives us a link to the page in the GD&T standard that talks about that particular feature. That's that right there. And then this GD&T proofing column shows any warnings or errors that may be present in any of the GD&T callouts. And so for example here we have this message, apply size tolerance to the feature or remove material condition modifier. And that's talking about our datum D here. So if we go to our feature tree here, we'll go to our datum D. So we don't have a tolerance labeled here, and if we don't have that tolerance, it has trouble evaluating it. So we'll just throw in 0.05 tolerance, and that resolves all the issues. And it's pretty much everything I had for you guys. Are there any questions? Or Adam will come talk about our next steps here.
Didn't we learn from Greg's GD&T class to be suspicious when the datum reference frame is the lower left-hand corner of the part?
No comment.
We'll make him defend himself.
Just curious. Sorry.
You're going to make me say that. Any designer, you know, all my prints are perfect. I don't know. Any designer doing that ought to take the stairs up the roof, do the armor. Because 95% of the parts in the world don't work that way. Does everybody agree with that? So if you want to see how quick you can reject a good part, keep putting that type of syntax on, right? But this was just an example of the type of syntax that they might see. So the documents say, hey, this is valid, not does it opt to reflect intent, right? Because the part might work that way, most of them don't.
So Jake walked us through design. That helps us set up all our GD&T, validate our GD&T, make sure we have no violations per the standard. Kind of our next step is we want to do our test evaluation, our perfect evaluation to see what our results might look like. Allows us to get a sample report to the customer, so before we start any work, we both agree this is what the report's going to look like. These are all the numbers you're going to get. I'm not going to put all your parts back up there and remeasure some feature because later you want that. We've agreed these are the features you're getting. That's an important part for us doing contract inspection. So I'll switch this over here to SmartProfile. It looks the exact same. So all of the user interface is the same between design and SmartProfile. In design though, we have a little bit more explanation and GD&T validation without the ability to evaluate. In SmartProfile, that's where we're going to hit our evaluate button. We're going to get some real numbers out of what we've set up here. So on my CAD surfaces here, I can generate some points, and I'll just do a fixed number of points on all of my surfaces. And instead of some random distribution of noise, I'm going to consider all my points perfect, 0 deviations, and I'll see a set of points here now appear on my part. So probably oversampling from what we would do on a CMM or a video system, but it might look more similar to a sampling we see from a scanning system, so structured light, CT, laser, whatever that might be. All I need these points though is to be perfect on my model, so I can click my evaluation here. SmartProfile steps through this and says, hey, I had 3 linear tolerances or size tolerances that all passed, and then I have my 7 GD&T callouts as well. So good news, I got all passing results. That was an expectation. We can see a summary of all of our results here, reading zeros on everything. We can view these all as characteristics. So from this point, I could create my PDF report to send to a customer to say, what specific features are you interested in seeing, maybe a more detailed view. On any one of my call outs here, my profile, I can display the results for just that call out to show point deviations on a specific feature. So maybe they have features of interest where they really need to know what the form or the deviations look like on just certain areas. We can create these specific views for PDF reports to pass those along to the customers. Also, most of the time though, we're just going to have some Excel report, so we can send this data to our SPC to get it to our standard AIS report, or maybe they're just going to use a generic SmartProfile report. In here, we have our Excel report button. It gets us a nice visual of all of the data that I see in SmartProfile, but in an Excel report. This is really nice because it takes snips of all of my characteristics, so I can see the GD&T callouts as they are on the print in my software in an Excel report. So it just kind of helps with visualization. If I set up my project property and labeled all my dimensions like Jake was doing, they would all fill in here too. So I only have one of them labeled, but they would all populate. That's kind of our step in the meantime before we pass it to an inspection software, so we can run a basic evaluation and agree with our customer to say this is what the report's going to be, so we don't have questions later in the process that require rework or anything like that.
So now we can actually involve our very expert PC-DMIS CMM programmer that Jake would pass to him and say, okay, we're ready to go, get this job on the schedule. And then in the case of PC-DMIS, John would be assigned, okay, here's the project, create the program. And so in the most commonly used format, we've got a CAD nominal file, and he would look at the PDF to do it all in PC-DMIS. Here we're going to say, well, the import in is the QIF file. And the hard part here is that we actually have to switch computers and make them work.
Success. So we've got the model, whether it came in from the customer as a QIF or Jake, one of our sales guys, did it. We start off creating a new program. Tell it a probe. And PC-DMIS with measurement strategies, it's going to be somewhat important. I found out when I was working on this. There's factory defaults, and those are great some of the time. So if we start seeing a lot of these QIFs, which we're going to coming from design, as PC-DMIS, we're going to have to go in and set some measurement strategies. Measurement strategies are, hey, if I have a cylinder, do I want to scan it? How many levels, how many points, how fast, how slow? Do I need avoidance moves before and after? So all those get set. And now we're ready to bring in the model. And it's an easy drop that in, excuse me, and it's asking, hey, I found 12 GD&T commands. Do you want to write the program? Yes, I do. Generated all the code. The first thing it asks is, do you want PC-DMIS to optimize the probe path? And here you can say, nope, I want to handle that myself, or we're going to say yes. And we gained 53% by letting PC-DMIS do it. When it came in the first time, PC-DMIS just said, hey, look, I've got all these features. I'm going to put points on them. Now it's optimized for for movement around the machine. We go here, and this would tell us if we have any features that don't have any calibrated tips, or if we have any features that just don't have any tips. We couldn't find one in the probe file. One thing in here, let us go back. You can set up so it will automatically insert tip commands. it takes a while and it takes longer than I wanted to spend doing this. So mentioned a couple of times, people have asked about, hey, is this going to eliminate a job? It's not. It's going to make my job a lot faster. I've got this program written now. What I need to do is I need to go around and make sure it's not going to run into it. So I'm going to add some tip changes, double check the GD&T. As you can see down in the bottom left, there's a couple of things that have failed. We can hover over. This one, it just says feature scan 7 does not have any measured data. If I go over here and look, scan 7 is in there. Well, that's what's inside there isn't part of my GD&T. All the GD&T is coming off this cone, that surface. The model, when it came in, it had all those surfaces selected as one. So PC-DMIS said, hey, I'm going to put points on it. We don't need the points. So I can go find scan 7, can delete it. And I've got 3 more in here, 4, 3, and 2. They're all right here together. And they're done. So now we're left with one thing. And what we've got here is, if I double click this right now, this message is going to go away. When a tolerance specifies more than one considered feature, all the features must be the same. So this particular call out is for profile from A to B. And that is these planes, this little notch in here with the planes, this radius, this plane in here. The problem that it's having is, has a bunch of planes and a radius. We can't put all those. PC-DMIS in GeoTol won't take all of those into one thing. So to fix that, we go in and we make a feature set. And we start grabbing these points. Create. Go back here. I'm gonna get rid of all those. All I want is scan 2. And all of this looks good. I like clearance cube on square parts, so we're gonna turn that on. Manual mode, I can turn that to DCC. That's a bad plan. Don't do that without a manual alignment. The machine has no idea where the part is. Some other things you have to add. You know, at this step, we go below the tip, below the load probe command, put in a manual alignment, and move on from there. But we can execute it.
Kind of sounds like you're in front of a slot machine.
Yeah. He's never won yet, though. No money has come flowing out of the CMM yet.
Yeah. I've got my speakers shut off, but when you plug in, it overrides that. So.
Question.
Yes.
So is this like a QIF mode? Like the reason I ask is this doesn't look like the PC-DMIS that I would normally see. You see like decoding on the left-hand side versus like planes, diameter. Yeah, that's what you would normally see. Okay, so I wondered, is that just bringing in the QIF, or is that just like an actual feature that you?
That's how I had it set. I had it set to summary mode.
Oh, okay.
Everything with this project, summary mode, everything's pretty much right there in one screen. If I go to command mode, you see everything that's in there, which is fine.
Right.
That's what I normally run, is like this, but
the PC-DMIS wise, really makes no difference.
Right.
Once you're into this.
This is PC-DMIS, that's it.
Okay, I was just
Yep.
wondering. I was just wondering.
Yeah, sure.
John, are you afraid of Bitcoin?
No. I'm marginally opposed to this view.
John, you just want to go through how you get between the two, jump between the two. So this is a reduced view, right?
Yep.
It's all one line for everything.
Yeah. So if we just go to
read sometimes.
Yep.
You just go to view.
View, and we've got command mode and summary mode. That takes us back to command mode. Everything looks like what you're used to seeing. And then back to summary mode if you want to see it that way. So,
Everyone has this in their software right now. It's not like we can add on or anything like that. No, right there.
yep. So what we've talked about is, hey, we're going to use SmartProfile for the analysis. That's how we're going to evaluate everything. Right now we have a PC-DMIS program. We haven't done anything with the points.
So I have a question. Are you going to spend the time to do the geotol dimensioning in the PC-DMIS program when you're going to eval?
So when you bring in the QIF, it automatically does it.
So you don't, I guess it's no time constraint?
It's no time constraint at all. It's a way to, kind of validate.
Gee, do the answers
softwares. Yeah, are we getting the same answer? Why aren't we getting the same answer?
Yeah.
That's a whole other conversation.
Yes, yes.
How does it know how you want to orient the part in the machine?
So it's going to come in. It's going to come in based off of CAD origin. Okay. So I brought it in, and when the model was drawn, they said, whoever made the model said, you're going to put it on the CMM. That's how I'm going to make it. So.
What about fixturing, or how are you going to hold it like that?
So what I did, Jordan's got a little thing, 'cause we've measured this part. I put it in a vise on the very bottom. I just clamped it in a vise. Does that work for everything? No. There's still management. This is something that I would send back and say, hey, it would sure be a lot easier if you'd change that trihedron. Give me a better way to do this. You can transform the model, but after the program's written, it gets a little fuzzy. Just adds more time. If they can do it up front and give you what you need, that makes everything go a lot better.
So how much messing around do we have to do after we make a program? How much time does a programmer actually have to go in there and sit and make sure that?
What we've got right now, everything's programmed. I left everything at A0, B0, which is going to drive straight down through the top of the part. So figure out where the probe changes need to go, put those in. I added the clearance cube. But you put a clearance cube in, PC-DMIS does on a square part like this. Even on a complex part, as long as you're not using a star probe, that's where it gets a little buggy with the clearance cube. But it sorts out your angle changes, so it's going to move to a clear spot, index, come around and measure a new feature.
Yeah. For the good news for all you folks out there that are like him, the need for him does not go away. We can just hire somebody, and within 2 months, they're going to implement this, and away we go. There's still a need for a high-level smart applications person, which is kind of a scarce commodity in this business. So whatever we can do to make these guys more efficient, to get that program done in a hurry so he can get on to the next one, is kind of the theme here.
I could go right there. I need a tip that's going to be A90B0 to catch datum A, which is back there. Scan 5. So at that point, that's the only thing on the back side of the part. So from there, you can come back around. Move that up one. So when it runs with the clearance cube, it's going to sort that out. You can also use clear planes. We haven't stopped any of that. I use clearance cube because it's quick and easy.
Collision. Do you run collision detection too after path optimization?
Yep, absolutely. That probably won't look very good, but it is there. Whoops. Didn't pick up the probe change. So while this is running, because even if I stop it, it doesn't stop, which is great. But what happened, I picked the wrong probe. And collision detection, absolutely. You know, doing something like this, I'm gonna run collision detection a dozen times before I ever put it on the machine. And then I'm gonna run it slow. So, but we need points, so we've got to get some points out of there. We're gonna go grab the features we want to send. And now we need to export them somewhere. And if we just send them to the desktop and we call it, give it a name, create. And now that goes, at this point, what we talked about was, hey, we've got this automated. I would send these points in to our network location where the projects live, the SmartProfile projects live. The point clouds do need to be named a proper way. That's what generates the files, the file structure. But as soon as the program runs, the points go into that folder, the project runs, and you start loading another part. You know, that's the automation side of it. So
we'll cover all of that at the end too. So
yeah.
Right now we're just going to look at ways of generating the point clouds, and then we'll touch on, once we have all of those that would be going to a central location, what do we do with them?
Yeah.
So the two biggest advantages are basically you get a nice exoskeleton of a program, and then your GD&T is entered correctly.
Yes.
And then, but you still have to go fine tune.
Yep, there's still going to be some stuff that, you know, just like on that one surface here, that cone, you know, the CAD model had this cone, the cylinder, and that drill point at the bottom, all as one feature. So PC-DMIS said, hey, that's one feature, I'm going to put points on everything. You know, the GD&T says, I don't need points on everything, I only need it on that big cone at the top. So.
Why's the scan on that cone look so scabby?
Because, Sean.
Just curious.
Yeah. So when it came in as a surface, it said, I'm a surface, I'm not a cone. So it scanned it. And the parameters that are inside the scan, and that's another thing that as a programmer you go and do. If we go edit that, we can change our start and end points and where all that is. PC-DMIS said, this is where I'm going to put the points based off of some numbers. So. Same with this one here in the middle. It did the same thing. It picked edge detection and said this is where the points are going to go because of what I've got for an edge offset.
Fair enough.
The nice thing I like, I've got my GD&T right there. Do I need a print? You know, if you have one, great. If not, I've got my GD&T right there in the graphics window.
Are they typically only looking for GD&T when you're doing the QIFs, or are they looking still for linear?
That, I wondered about that today, actually, and I don't know. If we bring in a QIF that has linear dimensions on it, I don't know what it does.
It'll do linears also.
It does do linears also. Thank you, Brian.
Distances and diameters.
Okay. Yep.
But they should define that before.
Correct.
So just like the GD&T and
Yep.
headlands, they would also define what you're measuring.
Yes.
Linearly. Okay.
Yep.
We had a customer come in a couple months back, and they had a new product they were developing, and everything was traditional tolerancing. Everything was plus or minus. I thought, well, this will be interesting. Let's try to stuff this through our model and see how it works. And it all worked fine. You know, within design, it supports all those traditional tolerancing kinds of things, and we got it done in, well, like half the time that we actually quoted it at.
Right. And then also you offered them Dr. Hetman's classes, right?
Yes. That actually was a suggestion.
So not to sound like a broken record to what the gentleman up front was saying, but so basically, when you tie in the programs all together with the QIF and PC-DMIS, except for fine tuning, it kind of takes the work of the programming out of it, correct?
Yes.
Okay.
Yep.
Hopefully half.
Right. Yep. You know, that's what we hope. That's what we hope to see is 50%.
But this won't put wrist moves in, right? It won't actually put...
It will. The reason I didn't do it, based on your probe file, if you have 40 angles in your probe file that you've pulled up to use, it runs through every feature and every probe angle, so it takes a bit of time to do that. I told it, I said, hey, don't insert the wrist moves. I'll do that myself at the end, is the way I handled that.
And Tom, if I was a QIF fanatic, there are means within QIF to get those wrist moves on.
Yeah, the measurement strategy that you can put into the QIF file can say, you know, first of all, what tool it is, what position the wrist would be at, how many points on the surface you want to pick. It can define, the QIF can define the whole strategy by itself. If that's there, you just consume it and run with it. You know, if it's not there, then you do supposed
But where our customers are going to say, hey, I've got a QIF file, but you know, they don't know if we're going to put it on a scanner or on a CMM or on a vision system, so we're happy just to get the QIF file with the embedded tolerancing in it.
Yes.
So if the QIF has that measurement file in there, you can guarantee that it's not going to crash on wrist moves?
Depends how good the guy who makes it.
I'm never going to guarantee anything. So, like I said before, you know, this is all the full picture of MBE is pie in the sky. You know, everything is possible. But like that measurement strategy aspect, I can't speak for PC-DMIS, but I assume it's also true for them. Zone 3 on my side, we have the means of bringing in a measurement strategy, but it doesn't consume all of the potential parameters that you can put in QIF. You can go really deep and say, you know, coverage is 80%, and you know, use this you know, probe and this angle, and really define it down to the nuts. Whether a software can consume all that information, that's a different question. So there's limitations on the CAD side with QIF. There's also limitations on the measurement software side. And the goal, you know, of all of us is to be able to consume that information, all of the information, and be totally comprehensive. And that would reduce any post work that would have to happen. To, you know, instead of 50%, you're now at 90%. You know, that kind of thing.
You know, in our case, the QIF came from design, and so good. These design guys, they understand the GD&T that they've put on there. It's a stretch to say for them to understand, here's how this CMM is going to work. We had some design guys in one time for a meeting, and we were talking about fixturing. And you know, this is a little flexible part. Fixturing was a huge deal, and so we asked, hey, you're the design guys, maybe you could give us the fixture design too. I said, fixturing? We don't know anything about fixturing. You're the measurement guys. You figure that out. So the more burden, you know, in the perfect world, the design person say, okay, I know how to make a fixture. I know the machine this is going to be inspected on. I know, you know, all the wrist moves and stuff. But in reality, they don't know that, but he does. So when it gets to him, he could say, well, I'm going to shortstop this thing and put all that stuff in QIF. Probably not very efficient. I'll do it right here.
Right. Yeah, I think I just speak for every programmer for PC-DMIS that anytime you see the wrist about to move, you kind of
yeah. Oh yeah.
Hold on.
Yes. Yep.
I'm curious. I think I heard you correctly and understood you correctly. Typically, first thing I do is I pull in a model and I transform the damn thing so that it's sitting right for my machine. Are you telling me I can't do that anymore with this system?
No,
okay.
I'm not. I didn't try it on this one because I just stuck it in a vise when I measured it on the machine.
But if I transform the model, that's not going to break any of this QIF stuff.
It's not going to break any of the GD&T. It's all your points are going to stay where they were until you do a manual alignment and start running through it. Yes. So, but
then I misunderstood.
If you have to do that, you know, it might be easier just to go back to the design guy and say, if you can, you know, if we have design guys for SmartProfile, hey, turn the trihedron for me. You know, make it so I can set it down flat and make it easy to measure. So
that's nice. That's a nice thing to have, but a lot of times you're sitting there at the machine
yes.
and you're ready to go, and I got to get moving right now.
Yeah, absolutely. So.
John, can you open up that measurement strategy? Just go through that just really quick, just to kind of tie this up. So you're going to set all your measurement strategy stuff for points, planes, circles, cylinders, right? You're going to set all that first, then you're going to bring your file in, and it's going to apply those strategies, whether it's 3 rows on a cylinder or a scan, or touch trigger points.
Yep. So I set it up for a plane to do 4 hits per row, 4 rows with a boundary offset of 0.5 millimeter, no avoidance move, and said I want this to be under my QIF profile or measurement strategy. Same thing for circles, did the same thing for cylinders, and cones, and then cones didn't matter because it scanned all of them with a linear open scan, patch scans. It actually put patch scans in for everything. So.
You said that's because it detected it as a surface?
As a surface and not a cone, yeah, because it had all that other stuff tied in
Is there a
with
way
it.
to define surfaces in the measurement strategy editor, or no?
No.
Just assume it's a scan?
Yep.
Okay.
Yep. So. Anything
Like
else
I
about
said,
this?
I said this earlier, but just to reiterate on the same topic, you know, the definition of those default strategies, whether they're in PC-DMIS or whether they're in Zone 3, or whether they're coming from a designer that's putting it into the QIF file right away, that's the expertise of the programmer. They're going to say, I want a strategy like this because I know that's going to give me a good result on the cylinder, for instance. And so those default strategies are what you're setting up, and then it just consumes those and applies it to those types of features.
Anything else? All right.
Well, it's not a PC-DMIS problem, it's an OGP problem.
Yeah.
And so Mike can show how he would deal with it. Now, again, I mentioned at the beginning that, you know, PC-DMIS 1990, kind of a special, so that is 33 years of PC-DMIS licenses being out there. During much of that time on the OGP side, it was MeasureMind and MeasureX, very limited CAD capability. OGP kind of recognized that, and over 20 years ago they began the development of a CAD-based solution to take the place of MeasureMind, MeasureX. That is Zone 3. So Zone 3 has been out for 8 years now, but it was long under development, and in reality it was some Hexagon guys who had some early involvement with some of the exact things within PC-DMIS. They moved on, they resurfaced at OGP. So, you know, again, you know, a lot of really smart guys with similar kinds of outlooks and capabilities helped build this.
So you won't be able to use this in MeasureMind if you have MeasureMind?
No, there's a path from MeasureMind to Zone 3, but MeasureMind has no CAD import capability of any significance.
Brandon, you can open a MeasureMind program, you know, write a Zone 3 program.
There's a translator.
If you have a MeasureMind program and you want to go to Zone 3, you open the MeasureMind program and it will create a Zone 3 program for you. Translate.
That's in all Zone 3 packages, it's included?
Not MeasureX, only MeasureMind.
Yeah.
So I can take all my MeasureMind all my MeasureMind routines and they'll transfer over? Is that? Oh, he knows I will.
So yeah, you can bring those in.
Speed it up too.
Yeah, you may have to do a little bit of adjustment as far as like maybe a little bit of lighting changes and things like that. But overall, you can set that with like some global editing and stuff as well. So it makes it, you may get like 99% of the way there with very minor adjustments, but the basic essence of your program, how it's measuring the alignments and everything like that, all of that translates straight into Zone 3 without any problems.
Chris will prove it to you.
Michael.
Yeah, we'll figure it out. So within Zone 3, similar to some of the stuff that John kind of set up prior to this, one of the first things we need to look for, again, is kind of our measurement strategies inside of here. So we'd have some step templates inside of here. So I've got a few options down here. I could say, you know, I've got some parameters if I want to measure a plane with the laser sensor, if I want to measure the plane with a touch probe. In this case, if we were to measure that part in a flat orientation, I don't have an indexable head on an OGP system, so I maybe need to use a star probe in order to do that. So I'd have a probe strategy that would include star probe parameters as well. So once we've got some of these step templates put in place, we could just go right to work importing our CAD. So we can go right in here, we could pull in our QIF model. Zone 3 is going to ask us, say, hey, we're currently in millimeters. Is your model in the correct units? You can make a change here if you need to. In this case, we're going to keep it in millimeters. And similar to what John was saying, it imports the CAD model in the orientation in which it was designed. Okay? So in this case, within Zone 3, I could very easily come in and just say, I'm going to rotate my model 90 degrees. So now if I look at it and I turn on the kinematic display for my actual machine, I could see that I have my CAD model be sitting flat. In this case, I would want to elevate it up off maybe in like some 1, 2, 3 blocks or a clamp of some sort so I can get a star probe underneath there. So once I have my CAD model in and I have it in the correct orientation, as soon as I hit save, I'm going to get a prompt on here. So what this is going to tell me is, hey, we recognize that there's some features and some tolerancing inside of this CAD model. Do you want to go ahead and add this into your program? So I come in here and click yes, it's going to pull that geometry in, and now I'm getting a prompt right up here. And this is going to say I have these planes, I have these cylinders, and from this list I can come in and I can add in my probing strategy. So I happen to know that the very first plane is the bottom of my part, so I need a star probe for that one. The rest of these I can come in and say maybe I want to measure these top, or the two side planes with my touch probe, and then I've got an inclined plane on the front. I'm going to measure that with my laser strategy. Okay. And then down here for my cylinders, I can come in, I'm going to say I just want to use my cylinder with a touch probe strategy. And when I've got all in there, I can click generate. And if I go look at my first routine, I now have all of those features on my part with the strategies to go with it and the sensors already set up for it. So in this case, if I open up my first cylinder, I'm in here using a touch probe, and I can preview what that probing strategy is going to be for that geometry. So in this case, it populates all of our features, and similar to what John was saying, we still have to do some stuff. Maybe we want to go and we have to add some manual alignments so we can say, hey, this is where the part's located on our system. And in this case, it's going to try to run, a traditional probe. It's going to switch over to the star probe for the bottom. So the order needs to be adjusted on here. So one of the things I can do in Zone 3 is I can come in here and I can optimize my entire program, and I can go with sensor ordering. And so now when I click OK, it's going to change the order of my features and combine everything so it's based on one sensor. So I'm not having to go back and forth and switch between a regular probe and the star probe and back to the regular probe and the optics. It bunches everything together and then optimizes the tool paths to run this as efficiently as possible. So once I've got that done, I can just click the run option on here, and we can actually see different sensors running around simulating the same thing that John would have done inside of PC-DMIS. When I hit stop on mine, it stops. So in this case, we could run on my program. I can come down here and I'm going to say I want to send my points out to my file. So once I've got that done, I can just apply that to all the steps of my program. So I can say update selected, put my file output on all the steps in my program. And then down at the very end of my program, the last thing I'm going to do is I'll just add a file output. And I can select all my features to put in here. And then I'll just adjust my template so I've got it in a format that's going to be compatible within SmartProfile. And then I would just adjust the file location. So in our case, we'd send it out to our point server. So when that point file shows up, it automatically goes and finds my SmartProfile project associated with this. It'll do all of the automated generation from that point. So.
Hannah, when's the OGP user group? May 23rd, and a part of that is going to be showing the Measure Mine to Zone 3 progression, along with great incentives to do it.
And then there's one other thing you get with Zone 3, kind of something Tom had mentioned earlier, in the fact that it also has a link with the design option. So if I create just a brand new blank Zone 3 project with nothing in it, I could start in the design software. Okay? I could come in here and I could choose my features. So datum D. Right down here, I've got this option for a measurement strategy, and it's going to read in those strategies from Zone 3. So I can come in and say, I'm going to measure that cylinder with a touch probe. I want to measure this plane down here, which is the bottom. We're going to do that with our star probe. So I can go through on each one of these features, and I can apply my measurement strategy directly from design. I'm not going to put all of them in there, but that's enough. So once I've got this done, right up at the top here, we've got an option that links directly into Zone 3. So as soon as I click this button, it says, hey, we found some entities inside of our CAD model. Do we want to put that in our routine? And say, sure. That same window pops up where I was assigning all those strategies beforehand. In this case, they're already being populated as we're sending that data directly from design into Zone 3. So in this case, as soon as I hit generate, I go right back into Zone 3. I've got my model in here. I've got all my steps inside of here. I could come in, just simply say, let's optimize this. Go back in, add my file output at the end, make some manual alignments as needed, and just like that, I've got a program ready to roll inside of Zone 3.
I didn't see you make any optical features in there.
So within Zone 3, there's a little bit of an issue currently. It's stuff that's kind of being developed with optical measurement. The biggest issue with that is when we're in there saying, I'm going to optically measure a line or an arc, it's looking at the tangent points between surfaces. So if you're looking at like the edge of two planes intersecting or the edge of a cylinder in a plane. So when you're looking at all the GD&T and all this stuff, like you have a lot of this is being generated off of surface features and 3D geometries.
Like where they meet as opposed to like the actual
correct. So
the
surface that we're trying to
be measuring.
Exactly. So if I've got a call out for like a counter bore for that cylinder, if I try to measure it as a 2D diameter on the top of that, I'm not necessarily gathering enough information to fully meet the needs of that. So that's something that Tom can speak to a bit more.
PMI information, is all on 3D features. So planes, surfaces, cylinders, and when you're measuring with video or measuring in 2D, those are 2D features. And so if you bring in a circle, there's no way you can attach PMI to it right now. So that's it's a limitation of QIF, but it's also a limitation in what we have. What I want to do is make it so that when you have a PMI connected to a cylinder, if I have a video only machine, I can choose to measure that instead of the diameter of the cylinder. I'm measuring the diameter of the circle instead and reporting that. Which is typically what you do with video. So
does it work with linear dimensioning then?
Or
it just doesn't work with?
It will work with linear dimensioning as long as they're related to 3D features. Plane to plane, cylinder to plane, those linear dimensions, yeah.
Back in the day when I used to have to do this, if I was in Measure Mine knowing it was going to SmartProfile, I would say, well, here, I'm going to set my top plane. I know that my depth of focus would allow me to go down 10,000ths of an inch. And so I'd go down 10,000ths of an inch and get my X, Y, and Z at that -10, and victory is declared, because now SmartProfile would know what to do with those points. They wouldn't be at the intersect point. They would be in the meat of what I'm trying to measure. Fairly convoluted.
The other thing is if you have like a sheet metal, which is what video is good for, is measuring with videos. But that's usually like a DXF file and not a 3D file. DXF files can't carry PMI either. So it's like this is it's really intended for 3D geometries, 3D models.
Do you have software that can generate programs based off DXF files?
Yeah.
And that is called?
You can do it right in Zone 3.
Yeah. It just doesn't have the GD&T embedded in it. But you can take a 2D file and you can actually automate a program without GD&T embedded, because it's a little easier on 2D.
And you can do that, so like using the step templates, you can also apply that to that kind of stuff. So if you had like a DXF file for a circuit board with 2,500 holes in this thing, you can say, cool, take this step templates, I'm going to measure this diameter with backlight and feature finder, cool, apply this to all the features that match that criteria, and instantly you've got your entire program populated after designing off and designing the feature off of one item in your CAD model. You say, cool, apply to similar, and it'll parse your CAD model and duplicate that for every instance in there. And you can do it straight with the DXF. No, I don't have access to that.
I have a question too. Can you change any of the strategies inside of using, if you just have a SmartProfile, or do you need design in order to define the measurement strategies?
You can define the measurement strategies in SmartProfile or design.
Okay.
Yeah. The definition of the measurement strategy, like how I'm going to do the strategy, is a template in Zone 3.
Yeah.
So you come into Zone 3, you measure a cylinder, you set the parameters the way you want it, and then it's saved, and then design or SmartProfile will see that.
Okay.
Yeah.
Can you do a head move in design?
Yeah. So head moves, PH10. We have CMMs also, and we put articulating heads on our multi-sensing systems. And the way that we treat those is different tools. And so the whole tool list shows up as in the sensor list. Drop down the sensor list. So that's the sensor list. It'll just show you every available sensor, and those sensors can be applied to templates, you know, for certain types of feature orientations or whatever. So.
Mm-hmm. Very, very good. Thank you.
Let me show one more thing. I just want to make one point. Go to my Metrology tree real quick. So,
oh, I need a reverse.
Yeah.
Yeah.
Yeah, you can show the whole workflow. But so this concept reverse programming, what I was talking about, where you know the report attributes that you want to report on, whether they're good or bad, and I just define those, and then it knows how to create the program from that. You can do that one by one. It kind of did it globally through the whole routine when he did it for the whole routine. But this is kind of a cool thing. Like here's your features from the model, and those are your tolerances from the model on the bottom. When he clicks on one of the tolerances, all of the features that are needed to measure that are in blue. You see the highlighted blue ones? Those are the datum features and the features that are needed. So it knows if you want to report that, I'm going to create all these steps. So he does that, applies strategies. So now this program only has those features and the one GD&T tolerance. So you can step-by-step through it like that too. Because inevitably, a model is not as simple as this one. You're going to have all sorts of crap on it. You know, so you might want to just measure 10 critical features or whatever, and this is a more effective way of doing it. I like it, reverse programming. I'm trying to make everybody remember that term. Reverse programming.
Thank you. Thank you. And now Jim has the easiest job of everybody because with a CT scanner or a laser scanner, there's no probes, there's no head movements, there's hardly any fixturing. It's just dispatch this thing into this CT system and get a whole bunch of points. But now the problem is that you got a whole bunch of points. So Jim would talk a little bit about how same part, but now we did it in one of our CT scanners.
So yeah, I'm lucky. I don't need a model to create my scanning program. All I have to do is worry about how I'm going to collect the points, basically. So I've got my part set up here with a really high-tech foam fixture, and we're just going to push go, and we're going to watch this thing scan. And then when it's done scanning, all I have to do is go to my reconstruction. It is.
That was 2 of 1,400 moves. How many?
Check your check the HDMI cable, Jim.
Check the cable. Check.
Nope. Bummer.
So with this technology, you've been able to almost completely eliminate any VG programming? Or what do you guys use for your programming?
We would in most cases run through VG because it has some superior point definition properties, surface definition. So even without the CAD data, I want to define where that, and so VG is really smart to say, well, I got some porosity here and I got something over here, but now I've got my actual surface. VG does about as good a job of anybody of just, it's transparent, it's just running through it, but we stop there to do the surface definition kind of stuff. And the hope would be, our CT system is RX Solutions, and they put out an STL file of what they do, and it's our hope that they get smarter and smarter and smarter at doing some of this, but right now, in most cases, we are going to just transparently run it through VG because they do the best job at surface definition. Did I say that right?
Yes.
You're gonna take the CAD model before and program it in VG? Or
No.
This replaces the programming side of it.
Yes. So all we're going to do, what you saw at the front end with Jake, whether it was a CMM, Zone 3, or a CT, we're done on the evaluation side. We've got everything we need to evaluate. Now the challenge is getting valid points to be evaluated. So, John says, here's how I do it in PC-DMIS, here's how I do it in Zone 3, and he's just going to say, well, here's how I would do it with my CT scanner.
So once I've scanned that part, I have to reconstruct it. I have to determine a surface mesh around that part. So what I've done here, you can see this red line here. I zoomed up here. Right now it's looking at that edge. It's using this basically sub-voxeling, which is kind of a 3D version of sub-pixeling, like a vision system. And it's finding a surface around there. So I say, yep, that looks good. I'm going to go over to reconstruct, and I'm going to do an export at STL.
So would you need a separate software for each type of equipment? Like CMM needs a certain one, CT needs a certain one, or that software will work for both of those pieces of equipment?
For us, for evaluate, so we don't care where the points come from. Something's got to make points, but then after that it says I can't tell points from points. I don't care if it's CMM points, vision points, or CT points. On the back end takes that file from the front end that says here's how you evaluate this. So all of the GD&T evaluation is happening in SmartProfile. And so that's the beauty of it, and that's why some of our customers say, well, hey, you know, I kind of get that maybe Zone 3 and PC-DMIS and Calypso and Metrology and Polyworks, they may not all give us the same answers. And so they're saying that we want answers from one place. And by the way, we validated this particular software, so that's where we want the answers to come from. So in our case, Evolve SmartProfile is, hey, it's sitting there waiting for points, and if the points come from the CT or the CMM or the vision, it don't care. It could come from a white light scanner or its laser scanner or whatever. It's going to say, okay, away I go. Now, Jim is going to give it millions of points that are going to be intelligently reduced, which is the another real powerful thing about SmartProfile is that, you know, in the world of GD&T, you own every point. And so if I own 100 points on this cylinder, I feel pretty good about that. 100 points well characterizes this cylinder. Oh, now you've got 1,000,000 points on this cylinder. Oh, that's nothing but trouble, you know, because, you know, flyers and this, that, or the other thing. SmartProfile has probably put more efforts into intelligent point reduction. It's not just going to throw out the highs and throw out the lows or do some kind of, it really gives you tools to say, okay, I got to get my, 100's my number. I know that 100 points in that cylinder will make me really happy. My metrologist judgment says 100 points are great. SmartProfile gives you really good tools to take the 1,000,000 and reduce it down to 100.
Kicks out the bad ones?
Intelligently.
Yeah.
We don't want to throw out the good ones, we want to throw out the bad ones.
Yeah, the point is it's without filtering. Filtering, well, depends on what you're doing, but filtering will typically smooth things, and you don't want that. You want to use real data. And that's what this sort of point reduction is. It's still real data, it's just less of it. And a good sampling of the goods and bads.
So this is my project from Jake. It's a QIF, and we imported that. It's all ready to go. All I have to do is import that mesh. Red part mesh. Okay, here's my points. I start out with 656,368 points. You can see the point density here from that CT scan. I can choose to do a quick alignment of those points, or I can set up a template with a CMM-like sampler where it actually reduces those points down to a manageable amount of points. I have this red part template. There we go. Oops, did that wrong here. Load template. Taking longer than it normally does. Okay, so now I've got these features with a quick alignment. My template had the quick alignment in there, so it automatically aligned the parts. And then I have this CMM-like sampler where I can go in and manage these points based on their surface. So if I click on this nominal feature here, it's basically setting up a search radius at each one of these points. I can change the density or the distance from the edge, the edge of the wireframe. If I change this to, let's say, 0.5, it increases the point density. My search radius, 0.5, I can bump that up. It'll take this radius and search for all of the points in that individual location and average them out to one individual point. There's other settings here where I can use the closest point to the center of that search radius.
So if I were to say, I want 100 points, we could set up that search radius to get the desired number of points. And so now I got these little hockey pucks all laid on here and say, okay, I got 100 hockey pucks, and in each hockey puck, I got 1,000 points. I need to get it down to 1 point, and that's where you've got different strategies. You've got a dozen different strategies to go from the 1,000 down to 1. And so in our case, what we'll do often is to say, okay, well, I can measure this thing on my CMM too, and I'm going to measure it on my CMM, and now I got really a high degree of confidence, and I'm going to see how does my point reduction number compare to my CMM number. And so if I get the same answers from the CMM and from the CT, I'm declaring victory.
So each one of these surfaces that was predefined by the QIF file, I can set up the parameters based on the feature size and the amount of points that I want in there. Once that's all done, I just hit done. I can preview everything right through here. Each one of these features lists the point taking strategy right down through this column. And then over here, I can look at basically how many points I started with and then what I've reduced down to, how many points I've reduced down. If I like that, I can hit done. Here's all of my points. They're already aligned. I went from 650,000 plus points down to 3420. So now all I gotta do is hit evaluate and I'm good to go.
And that's where for repeat measurement, a lot of this can be automated.
Yep.
So you're not doing this each and every time. Once you decide how to do it, all of this stuff just happens automatically.
That's all I got.
It's easy.
How come in the corner it says it run in 1994 for SME instead of the 2019?
Right here?
Lower right.
It's selectable within the software, so you can do 94, 2009, or 2018. It's all selectable.
Be based on here project settings. GDT.
Doesn't have ice. Oh yeah, there they all are. Look at all of them.
Yeah.
I'm not sure, does QIF pick the standard?
You can.
Could.
You can,
Mm-hmm.
you can,
Mm-hmm.
yes.
Okay.
Mm-hmm.
When that little send to zone 3 button from design, when it does that, it's sending it via QIF data. And since design is defined as standard and everything else, the standard comes over with it. So when it comes into zone 3, the standard is the same as when it was applied to design.
So with this, then you wouldn't have to write your VG program ahead of time. You could just import your
VG would just be one of the transparent things that it passes through, more or less.
VG makes the STL.
Brandon, what are you using VG for? Are you using it for reconstruction only?
well, we use it to write the program.
You want to take your point cloud out of your CT and bring it in a PC, so do that too.
You're reporting results out of there. The reporting results and the analysis can be bypassed. You just want to do it.
Right.
If you did it, yes, sir.
And again, VG does the best job of this surface definition. So, you know, we're in the metrology world. We're really, you know, in the old days, I'm just looking for flaws in my helicopter transmission. So I'm not concerned with sub-thousandth of an inch kinds of things. But now all of a sudden, bring CT into metrology, and boy, you know, I really need the best resolution and the best points I can get. And that's where for us in metrology, you know, these VG guys, they really do a good job of surface definition.
Yeah, and the way we kind of do it now is, so someone will let us know that they have a project coming up, they'll send us the CAD files, we'll write a program based off that CAD file they send over, then we scan it, and then we overlay that scan with the CAD file for the measurement. Right.
Yeah, yeah.
He's the guy who does it all.
Yeah.
You would get a validated program, it would be written for you, right? You're in the QIF file into VG and stuff.
That's where in the hexagon world, there's PC-DMIS, there's a package called Inspire, there's a volume graphics has metrology built into it, spatial analyzer. So there's all these different softwares that give you all these different answers in theory. And so PC-DMIS is kind of, from a metrology standpoint, the flagship of all of that. And a lot of you guys here know Rob Jensen. Rob Jensen was our trainer, and now Rob's job was to be the PC-DMIS GD&T purity guy. And so Geotol is really a lot of Rob's efforts. But now, since that's done, Rob's new job is, Rob, go to Inspire and get the GD&T capability of PC-DMIS to go into Inspire. Rob, go to Spatial Analyzer. Rob, go to VG. Huh? Yeah, and go to VG. Just like QVI, OGP, you know, if you looked 8 years ago, there was SmartProfile and there was Zone 3, and sometimes the answers were a little different. Where Tom talked about now, it's the same analysis engine. So you're going to get the SmartProfile and Zone 3 are going to get you the same answers. Hexagon says PC-DMIS and volume graphics are going to get you the same answers. That would be the objective, and then all we have to worry about are the answers the same from Hexagon to OGP. And you know, we sell both, and we've got a lot of confidence because we know these guys and we watch how hard they work and identifying discrepancies. You know, ask me about Polyworks, and well, I don't know about their answers, but for ours, we get a lot of confidence.
A good way to look at it is, you know, Zone 3 in PC-DMIS and volume graphics, they can all acquire data points by whatever means, you know, multi-sensor, touch probe, laser scanning, CT, and they can also all evaluate the results and give you a report, right? So you could, with that, in those cases, you know, you don't need SmartProfile, you can just report from those packages. But what Keith is trying to do in the standardization part of it is just use those packages for point generation and bypass the analysis and report side of those softwares and do it in SmartProfile. So that it's common, it's standard, and it's and you can do a lot of the kind of things that we showed.
Yeah.
All packages can evaluate and report. It's just a matter of whether you want to standardize and calculate it consistently throughout, independent where the points are.
Yeah, I mean, that's the whole issue of software validation. I don't think you guys run into customers saying, tell me about software validation. I was at one of our MedTech customers a number of years ago, and I'm talking to them, and oh yeah, we just completed our software validation of MeasureMind. And so, well, that's interesting, you know, show me what you got. And they had a consultant, they had a book this thick, and it says, you know, if you type A, does an A appear? If you hit the crosshair, does the crosshair appear? It had nothing to do with the quality of the answers. It was just validating all this goofy stuff. And yes, this is validated, and somebody say, you have validated software? Yeah, I've got this 400-page binder here. Here's our validation. Where, you know, validation for us should be, are the answers the same? And we got another MedTech customer that uses SmartProfile, and what they did early on, they said, okay, working with COTEM, we want to have 8 models, 8 sets of points, and we validate the next version. Bring in the model, bring in the points, what are the answers? And now 6 months later, the next version comes in. Okay, give me the next version, bring in the model, bring in the points, do I get the same answer? And so, you know, that I think is really software validation. And in reality, you know, somebody should ask that about everything. You know, show me your validation for every software you sell. not practical for us, not practical for most customers, but from our standpoint, say, you know, we do all our analysis in SmartProfile, fine. We've got a validation routine like this customer has. We got 6 sample models, sample point sets, and every new version, are the answers the same?
I have a quick question.
Yeah.
So from a production standpoint, if you know you're on the go, trying to get stuff out the door, I guess this is more kind of personal preference, but which one would you say would be the quickest way to get accurate measurements, but be quick about getting parts? Let's say you have 500 parts and you're constantly trying to repeatability. You know, what's the quickest way you think between the different ways of getting checking the part?
As far as the measurement system or software, or?
Yes, more so software.
Yeah, you know.
What are you currently using?
Right now we're using the PC-DMIS.
You know, if it's a.
Maybe I guess
yeah.
I might ask that question
Yeah.
wrong. Like out of the different methods, which one would you use?
Well, if it's a, you know, the part kind of dictates it. Say, this is a part for a tactile CMM. Or, man, this thing has got features that are 0.004 of an inch wide. How am I going to do that? And so, oh, that's more of a multi-sensor kind of thing. So the nature of the part kind of sends us down the machine path.
And we wouldn't.
But we always have probably, you know, you want to, what do I have the most confidence in? Something going beep.
Yeah.
All of the analysis solutions that we've talked about, we wouldn't say any of them take any longer to do than the others. And we go down SmartProfile path the most, and it is an outside software, but we can help you get that set up to a point so it's no additional work, right? We don't want you to, we've seen write the program, export the points, load the points into SmartProfile, click evaluate. You could do that one-off. We don't do that in AIS. What we're going to show here, we run it all automatically. So we set up the SmartProfile project once, and from then on, we're really never interacting with it again. We're just sending point clouds to it, and it's going to evaluate for us. So the goal of it is not do more work, use this software because it's better. It's supposed to be the same amount of work that you have now, right? We're not trying to add more tasks or things for you to do. So we're going to go through some of our SmartProfile automation. In our lab AIS, we use a ProLink product, QC-CALC, or real-time, either or, to collect our data as our kind of data management. We're going to put all of our data, evaluated results, into a SQL database. That's our ProLink product here. And so we'll kind of step through, hey, I have a whole bunch of point clouds. These will be coming out one at a time as I'm running my CMM, but I'm just going to drop them into our evaluation folder. We'll see how it goes here. So we're going to do this all here. We've got our script that runs all the time in our lab, so anybody on any machine in our lab can write the point clouds there, and it's going to start the evaluation for us, as long as we follow some basic naming conventions. And for us, we look at our job number or work ticket order, like the drawing number, some unique identifier for the project that we're going to look for, and then a serial number, a part number, a piece number, something along those lines. So we got our 10 runs that John did for our repeatability test here on a CMM. So these are XYZ files, but it could be any point cloud file. We don't care about file types. And I will take that to our SmartProfile evaluation structure that we have here. So we got job numbers of all the previous things that we've run through here. But we have our main point cloud folder that's always looking for point cloud. So as I drop files in here, you'll see it start to append some of the file names where it adds a unique date and time. So we'll never overwrite any files that we have in here. We can see the list starting to get smaller and smaller and smaller. So it's grabbing these point clouds and it's evaluating them in SmartProfile as we speak here. My real time would update if I was doing it on this particular PC. But if I click refresh now, I'm starting to see my results here in my SPC software. So I can see these charts
from anywhere that I can connect to this database. So again, running this in the lab, we can see this all over. Refresh one more time here, we should get our 10 results. Once it gets happy with me, it's just not displaying them. It takes a second to update sometimes. But it's no additional time in the inspection sequence. By the time I have a part out of a fixture, it's already going to be evaluated in the SmartProfile. I'm not behind the ball or the process in any of that. So we don't want it to be considered extra work, added steps, stuff like that. We did all of the work for SmartProfile at the beginning of our job intake where we set up the project to kind of confirm with the customer this is what you're going to get. Once we've agreed to that, it's in our evaluation sequence and we don't have to look at it again. So again, it can be very, very automated. Once the data is in QC-CALC, lots of reporting functions you can do with that. We got our friend Jordan here who's going to come up and talk about data management within QC-CALC, reporting within QC-CALC, how we use it. So that's you, Jordan.
Oh. You're quicker than I thought.
It does it all itself. There's nothing we gotta see. All your stuff should be up.
All right, I got a little bit of some slideshows for you. Keith talked about this a little bit earlier. Data gauge capability test. By the way, I'm Jordan. Forgot to say that.
Hi, I'm Jordan.
Application engineer, PQI. Do some data stuff. QC-CALC is my main thing. Here we go. So the data gauge capability test we were talking about. Before we start running parts for the inspection, we want to make sure everything's in place. Everything we expect to happen is actually happening. What we want to do is we want to check that the part setup is complete. So that means John or Mike, mostly, working on the programming side on their machines or their inspection equipment. That's complete. All the features are there and ready. And then we want to make sure the fixturing is set up properly, because that can be kind of an art in itself, playing with Legos in a sense, making sure it all kind of fits together. On top of that, we want to see how repeatable the set gauge is. Can be varying quite a lot or not at all. Worth checking out and looking at. And this is all during the prove-out phase, so-called, which happens again before the actual measurements occur. So what's our plan? We want to measure 10 parts, a subset of the total features. That could be the full set. Say we have 20 features, we can measure all 20 features. That's not too long, but say we have 300 features. You probably don't want to run that 10 times because that could take a whole week in itself. So we grab 15, 20, somewhere around there. Critical features, easy, hard features, whatever you really want to do for that job. If we want to do 5 runs in the fixture, you put the part in, don't touch it, and you just run it. And then you want to do 5 runs when you put the part in, measure it, take it out, and then replace it. It's only one part, not changing in and out. Once we do that, we look at the single part gauge repeatability report that QC-CALC generates. This is a PT ratio, precision to tolerance. Anyone heard of that or use it? Excellent, we're all on the same page. QC-CALC defines that as the ratio between gauge variation and specification range of each feature. Basically just looks at how much the gauge is varying with the total tolerance available. And this isn't a substitute for the GR&R, gauge repeatability and reproducibility. You've probably heard of that. It's just an initial look at the gauge and perhaps gives you some insights on what actions you might want to take later. And that can be, if the PT is under 10% or less than or equal to 10%, you're probably pretty good. It can actually start the measuring process. If not, if it's between 10 and 30, maybe start looking at how can we fix a couple things, either in the measuring or the fixturing. And if it's above 30, probably 30%, probably some major revisions need to happen somewhere. So these are some results. We just saw this from Adam. These are some taken earlier. We got all of our features, all of our characteristics and runs. We got 10 of them, 5 in the fixture, 5 being taken in and out.
So when Adam had his up, he had CPK as the little indicator there in the lower right or lower left of every plot. But that is selectable. I want the range, I want the standard deviation, but one of the selecting items is PT ratio. Oh, perfect.
Keith beat me to it. Circled it right there. That is the ratio. You just look at that when you're running the parts after the 5 or 10, because right here this is just the in and out of fixture. And QC-CALC has some reporting capabilities.
We're going to look at that right here. This is the actual report I was talking about earlier, and these are some results. On the far right is mostly what we're interested in. The far left shows each feature's name. We want to look at the percentages. If it's below 10% or less than or equal to, probably pretty good, ready to go. If it's higher, then more inspection or more evaluation of what's going on is necessary. And I want to highlight one in particular, one feature, number 26, I suppose. That's at 18.6%. That's above the 10. What we mean, or what we should do is then look. That could mean the actual part, or the gauge itself is wrong. Could mean the fixturing is needed to be improved upon. So then we break it out into those two setups we had, the 5 in, the fixture, the 5 being replaced. This is the in fixture data. That same feature, 1.2%. That's pretty good, less than 10. So that's probably not the case, but if we look at the next one, 27.4, that's pretty close to the 30, which would mean that this is the in and out of fixture data. The fixturing probably isn't ideal. So I showed John this, and he said, yeah, we just kind of clamped it there, you know, just kind of initial inspection.
When I talked earlier that you just put in a vise, well, Jordan ran some of the parts. I thought he'd be real good at putting it back in the vise the same way.
It's always the operator.
He has too much faith in me.
So we would stop here and say, look, I got to do a better fixture. You know, I've got to add a clamp. I've got to get something 3D printed. Something at this point we would stop and fix the fixture.
Fix the fixture. Or the operator, as Jim just said.
Training. It's a training issue, not a fixturing issue.
Yeah, that's the easy one, right? That makes sense? Everyone agrees, probably the fixture? All right. Now, part 2, I want to give some tips on data management. What can that mean? That's a lot of things, right? We house our data in QC-CALC and SQL Server. My first tip, use a robust management software. Ours is these again right now, amongst many other things, but these are the ones that I work with the most. The benefits of these two, compact and a centralized storage location. That means one file or one group of files is housed in the network, and everyone can really access it. That's the third point. I could be right here, and in fact I am right here, accessing the data in the other building. And then it's user and password protected as well, meaning not anyone can just go in and do stuff. Only allowed people with the proper credentials and abilities can actually access, manipulate, delete, update the data, stuff like that. So I'd give John some of those privileges, but probably not all, because you never know what he can do. Another tip, automate those routine actions. I'll do a little bit of that in about a minute, but that's again with QC-CALC and another ProLink product, SPC Office Buddy. But once we have the data, what are we going to do with it? A lot of customers, which is fine, don't really do much with it. They just collect the data and they just kind of have it, which, you know, looks nice, but we can do more with it than that, right? We can make educated choices for the future. And we can do that by analyzing various reports, such as 6-packs or stat summaries, really any SPC reports out there. And then we use those to notice trends. Say we see, well, for us, as the contract inspection, we don't really have control over what happens at the manufacturing until after it's done. If you're a manufacturing plant, you're looking at parts pretty quickly after they've been made. You can see, oh, these parts are trending upwards. That could mean a tool's about to break or something similar to that. For us, we just say, hey, that's kind of how it is. We also create custom reports in our Excel sheets. Excel is one of our favorite things, and we can send that, all of our data, to an Excel sheet that we then give to the customer, as we've mentioned several times here. And I want to show that. This is Office Buddy. Again, ProLink product. We're going to open, when it wants to work, a file. Oops. This is our part, the one that Adam just made. Right there, 10 runs with a couple features. I have this Excel job, we call it, made for the AIS Excel sheet. What we do is we click play, we have all the things selected, characteristics and records. It's going to create an Excel sheet and start populating it. thing wants to be in the way, but it's just taking all that data from QC-CALC and putting it there. And normally it's a bit faster, but it's for some reason a little slower. But it looks pretty cool, right?
You're very productive.
Just get to watch it. Now that's it. So it saves it to a network location after closing itself. There we go. And you can see, you know, red, not good all the time. But you can go through, that's all of the parts, all the features. On the left side of the feature names, Office Buddy takes whatever is given to it and just exports it for feature names. We won't want to give this to a customer because well, you can figure out what demo 1 means, but there might be easier ways of looking at it or more nicer ways, which is I built a parser that converts this left feature name to GD&T, uses the GD&T font, and it actually displays any callouts there. Some customers like seeing that, some like the words on the left. Tell whatever they want, really. Any questions?
Yeah. And on this, it's interesting, like, you know, sending all the data to SQL. We work with customers who, in the old QC-CALC world, it was all these flat files, well, file after file after file. And now we say, hey, we're going to send all the data to one common database, and they had lots of trace fields. And back in the day, everybody, you know, oh, it's Bob. No, it's Robert. No, it's R. Smith. And so they put all this information in differently, and it was a disaster. But then over time, all the trace fields kind of get squared away. So like what we did, you know, we said, well, I'm in the prove out. So I've got my file. I'm in the prove out mode, which just means I'm going to run this thing until I'm happy. And when I'm happy, I'm going to say I'm into my gauge test 1 mode, which is in the fixture. I'm in gauge test 2 mode, which is in and out of the fixture, and I'm in, you know, the run mode, which is the actual data I want to collect. So it's all still there. So if I need to go back later and look at the gauge test, I can, and I probably never want to look at the prove out data, but other than maybe say, man, did I mess around a lot to get to something worthwhile. But again, the beauty here again is that it's all kind of automated. So from the stuff that Jake did, get the points, and then once the points are done, are starting to dump into the server, all this stuff kind of pees out the other end quickly.
It's all connected. Alrighty.
There we go.
Great. Who's after me now?
I don't think anybody's after you.
Wow.
Tom and I are after you. And so, again, you know, this represents how we solve this. And again, it was driven a lot by a customer saying, this is how you will do it. Oh, you're giving us lots of work. Of course we'll do it that way. And so when we get lots of work, it makes them, it's important for us to try to be as efficient as possible. The greatest project we ever had here, we had a customer inspecting some little seals. And it came in, and they say, well, you know, we probably need you to run this for, you got about 10 days worth of work. Oh, okay, that'd be fine. It's going to be another 10 days. Well, this is actually going to run another month. And so we got better and better. And what can we do better on fixturing? How can we set this up more quickly? How can we do our data analysis? And, you know, it lasted for 2 years. Hundreds of thousands, if not millions, of these parts. And by the end, it, you know, anybody, it was set up across the street with high automation. And so if there, you know, we were a little slow in electronics calibration, so the guy who ran the electronics calibration department, you need to run seals today, buddy. And so we, you know, automated to the point where almost anybody with, you know, 2-3 hours of training was running the process. And that was pretty easy, an easy application. Stuff like what we did today is not easy. You need guys like Mike and Jim to get the job done, John, but you can still automate certain things. So that's what we're always trying to work towards. Right now, we've got our calibration lab across the street. That is where our best environmental controls are. We're kind of moving some things around, and we're going to free up probably about a 500 or 600 square foot space in the environmentally controlled lab, and the theme in there is, you know, this process, how to automate, how to use software automation, how to use fixturing, how to use robots or whatever else for those long run jobs to get them more efficiently done. Well, that's our goal. And Tom, do you want to?
Yeah, I just wanted to touch on, you know, where the industry's going and where we're going relative to this. You know, like I keep saying it, but there's like the big picture of how, you know, all of this could work together to make it so that it's easy and the most efficient for you guys as customers. But we're not there yet. You know, we've got a long way to go. Made a lot of progress. You can see these guys showed all of the progress we've made so far, and what you can do now in reality is what you just saw. A lot of the things that we want to do going forward is above and beyond that. So some of the limitations that we talked about, you know, the 2D video kind of limitations to PMI, some of the CAD limitations. There's certain CAD packages that support this and certain CAD packages that don't, and a lot of CAD packages that you know, support some of it, not all of it, and you don't know what they support and don't. So it's a little sketchy on that side right now, but everybody's working towards the ultimate solution. Some of the other things that we're you know, planning on doing is getting into that Industry 5.0 stuff. So making things a bit more intelligent using this data. So once the data is available, we can start to get a little bit smarter about how we measure stuff. You know, so when I know that this particular feature has a tolerance that's really tight, and I'm able to use this sensor on this CMM, is that a good enough sensor to measure that part? Question one. If not, you know, you get warnings or you recommend the type of machine and sensor to use for that measurement. Should I use a laser measuring that part, or a touch probe, or a video sensor? What is the best kind of sensor to measure that feature? And we can use that intelligence to be able to not only automate the program like you saw today, but also automate the measurement strategy. A lot of the measurement strategy tactics that we used were kind of manual. I'm saying, this cylinder, use this measurement strategy. This cylinder, use this measurement strategy. But if we had intelligence on the uncertainty of machines, uncertainties of sensors, and the associated tolerances features, can marry the two. Another way to do intelligence is, you know, the idea of reporting a feature-based uncertainty on every feature that you say. So I'm 20% confidence that this feature answer is correct, or I'm 90% confidence, and then you dive into that and see what the contributing factors of that. Yeah, the machine has some uncertainty. Yeah, there's some temperature variation that contributes to uncertainty. I ran a 10-part run, you know, on this part, and the variability of the sensor or whatever is contributing to uncertainty. So in the design module, we want to have that kind of simulation so that we can predetermine, you know, what kinds of sensors we need to do based on those uncertainty calculations. Match those theoretical ones to the reality ones where you're measuring on a machine and say, do they match? No. All right, well, I'm going to improve my theoretical stuff. So it's all about making our software more intelligent, but the infrastructure of QIF, you know, all of the data, that digital thread behind the scenes that contains all the information, that information is useful. Just like anything, you can create tons and tons of data, and there's tons and tons of information out there. The hard part is using it and making it so that you can make good either business decisions or technical decisions from it. So, but you know, first part is you got to gather the data. The second part is you got to have a structured way to collect it and store it. And the third part is using it, evaluating it, and feeding back to the processes that you're using. So that's kind of the future of QIF. And I don't know, what would you say? How far in if you were to say, you know, this whole model-based enterprise or the whole QIF concept, how much of a reality is it? I'd say, I'd give it 50% right now, maybe 40. I mean, there's a lot more we can do with it, and that's what, you know.
I think on the adoption curve, it's been very, very flat.
Adoption's a different story.
It's going to start to knee up here in a big time. Dave Belko, who introduced, he's our hexagon guy, and when Dave was young, his first job out of college was with Unigraphics. And Unigraphics, you guys know Rob Jensen. Rob Jensen worked for FMC, and they had a partnership with Unigraphics, and FMC developed a package called Valysys in the late 80s. Completely model-based definition. And so, you know, that's like, holy goodness, this is 30 years and we're not getting anywhere yet. So 30 years ago, this was conceived and used, not successfully.
Yeah.
But I mean, Rob, that was his big job at FMC, was to do this, and then had GD&T checking, it would make everything blow up. And then so Valysys goes away, and now the next thing and the next thing and the next thing. So it's been a 30-year slow ramp up. And during this slow ramp up, we've seen nothing in our world until the last year or two, where all of a sudden QIF and some other things really make the model-based enterprise stuff reality, and we're actually seeing it.
The idea behind the QIF and why they developed it is so that we can use that easier and develop our software faster. And that really has become a reality that we are seeing the QIF is allowing us to kind of get to the reality.
All it took was Dave's entire working lifetime to get from concept to reality.
Yeah. Yeah. But that technology stack that I talked about before, you know, what do you need to make this a reality? You know, as the tools, hardware and software tools that you have available to you become more capable, then it's easier and more comprehensive, the amount of this whole workflow that you can get through. And we're getting pretty close. So.
Thank you. And then some other things, we try to do something like this several times a year. On April, a ProLink user group meeting. If you found out about this one, you're going to find out about that one. And so guys from ProLink are coming in to do that. And then historically, we've always had an OGP user group meeting. That's coming up in May. It'll be a lot of Zone 3 things, but also a lot of things about MeasureMind to MeasureX progression paths forward. In the old days, it was, oh, here's the latest version of MeasureMind. Here's what's coming up in MeasureMind. MeasureMind is end of life. So if something's broken, it'll get fixed, but there are no enhancements, but there are paths forward. And sometimes that path forward is not too painful. If I have a machine that's maybe in the last 5 years or so, or even a little older than that, I may have just a software computer controller kind of thing to get there. If I go back maybe 15 years and I've got a Quest, which is our biggest, largest, most accurate version, that's worth investing money into because that is still a very valuable machine. If somebody says, well, I've got a 2005 6x8 Smart Scope, well, maybe not so much. That we can sometimes take them and trade, but we'll talk about paths forward to get from MeasureX, MeasureMind onto Zone 3, and talk about what's new in Zone 3. Again, we always have done an annual PC-DMIS user group meeting talking about what's new on the software side, also some new hardware kinds of things. This is an Oktoberfest year, so third week in September. Again, the announcements will go out, and that will be with productivity. So generally, there's 1,000 to 1,500 people every day. Just a big open house, beer tent, all that kind of good stuff. But also there are seminars, and we're finalizing them. One of them, Tom, is coming back because he likes to drink beer with us at Oktoberfest, so we've got to find an excuse for him to come back. But we think a lot of this manufacturing project kind of stuff. So he showed you in the process flow, the manufacturing project gets into machining offsets and feedback to the machine tools using this same SmartProfile data. That's kind of the beauty of Smart Profiles. Okay, I got these GD&T problems. Okay, fine. Oh, I've got these traditional tolerancing problems, and I've got this manufacturing process control problems. Smart Profile gives you an environment for each, and probably one of the harder ones to conceptualize is all of those manufacturing capabilities. How do I recalculate these offsets? And then how do I feed that back into my machine tool? That would be kind of a theme of the Oktoberfest one. And then Jim showed a little CT stuff, and we'll have a CT open house in November. And every week there's some kind of training here. So PC-DMIS 1, PC-DMIS 2, PC-DMIS GD&T, PC-DMIS ARMS, Measure Mine, Measure X, Zone 3, some QC-CALC classes, Metrology Boot Camp. Maybe about it. So, thanks again. We appreciate it. You know, whatever we can do to help on this, especially if you got questions, Chris Carlson will answer all of them for you.